Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Yang kami hormati Ibu Taranita Kusuma Dewi selaku Ketua Program Studi Teknik Sipil UIN Maulana Malik Ibrahim Malang, Mr. Lordi Zevania MSc MSc PhD selaku narasumber, dan Mr. Hari H BE MSc PhD selaku narasumber kedua. Dan tak lupa yang kami banggakan segenap mahasiswa Program Studi Teknik Sipil UIN Maulana Malik Ibrahim Malang. Dengan senantiasa memanjatkan puji syukur kehadirat Allah Subhanahu wa taala, perkenankanlah acara webinar internasional dengan tema Structural Resilience yang dilaksanakan secara online melalui saluran Zoom Meeting pada hari ini 6 November 2025 akan segera dimulai. Perkenalkan, saya Husniatul Aini yang akan memandu acara ini sampai selesai nanti. Sebelum memulai acara, kami akan membaca susunan acara pada pagi hari ini. Acara yang pertama yaitu pembukaan dengan pembacaan Al-Quran. Selanjutnya menyanyikan lagu Indonesia Raya, Mars UIN Maulana Malik Ibrahim Malang. Acara selanjutnya sambutan Ketua Program Studi Teknik Sipil UIN Maulana Malik Ibrahim Malang. Kemudian dilanjutkan dengan pemaparan materi oleh Mr. Lordi Zevania. Materi kedua akan diisi oleh Mr. Hari H, dan acara pada pagi hari ini akan ditutup dengan doa. Baik, langsung saja menginjak pada acara yang pertama yaitu pembukaan yang akan dibawakan oleh Muhammad Zaki Zahir. Kepadanya dipersilahkan.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. Inna fi khalqis samawati wal ardi wa ikhtilafil laili wan nahar laayatin liulil albab. الذين يذكرون الله قياما وقعودا وعلى جنوبهم ويتفكرون في خلق السماوات ربنا ما خلقت هذا باطلا سبحانك فقنا عذاب النار. إنك من تدخل النار فقد أخزيته وما للظالمين من أنصار. ربنا إننا سمعنا مناديا ينادي للإيمان أن آمنوا بربكم فآمنا ربنا فاغفر لنا ذنوبنا وكفر عنا سيئاتنا وتوفنا مع الأبرار. ربنا وآتنا ما وعدتنا على رسلك ولا تخزنا يوم القيامة إنك لا تخلف الميعاد. صدق الله العظيم. السلام عليكم ورحمة الله وبركاته.
Okay, thank you very much. The next agenda is singing Indonesia Raya and Mars UIN Maulana Malik Ibrahim Malang that will be led by Miss Dewi Ika Safitri. For Miss Dewi Ika Safitri, time is yours.
cita bangsa. UIN ku lahirkan nurul albab, amalkan intan kita sepanjang masa. Lakukan iman dan akhlakmu, bangunlah bangsa dan negerimu. Ikhlaskan segala amal baktimu, untuk bekal dunia dan akhiratmu. Bangkitlah wahai mahasiswa, abdikan diri untuk bangsa. Universitas Islam Negeri Malang, jayalah untuk selama-lamanya.
Now?
So now it's 10 p.m.
10 p.m. Okay, thank you very much. Thank you very much, Mr. Okay. We do apologize for the inconvenience because the student come from the Pontian, in Malang, Batu, sorry. So there's any problems, please apologize. And all of the participants here from WINSA, Teknik Sipil WINSA. We also have a partner with Teknik Sipil WINSA, and for our students, civilians 24 and civilians 25 here. It is a very special to our speaker, that Mr. Lordi and Mr. Hari from NTST Taiwan became our speaker for the structural resilience topic about innovative strategies to mitigate aftershock impact and enhance concrete durability with autonomous healing materials. Hopefully, students can get impact from this webinar and get insight how about the structural resilience should be and how the structural resilience in the future. I think it's enough from me, so we can we can start the webinar today, and hopefully it will be successful until the end of this the day. Thank you very much for everyone. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Mrs. Taranita. And now it is time for the main session of today's seminar, We are honored to have with us our keynote speaker, Mr. Lordi Zefania and ST PhD, Project Assistant Professor, UTTP Paraguay, who will deliver a presentation on structural resilience, and it will be moderated by Mrs. Dia Nugraheli Satyawati, SDMT from UIN Sunan Ampel, Surabaya. Please welcome with a big round of applause.
Can you can you hear my voice?
Yeah.
Okay, that's good. Yeah.
But I can see your face.
Oh really? I
Yeah.
already opened the video.
Oh, maybe there's a problem then. So your
How
video.
about now?
Yeah. But it's okay.
Can you see my video? No?
But yeah.
But you still can see my face. Is that Vicky? Can you see my face? Yes, I can see you. Okay. Okay, so yeah, first of all, I would like to say thank you for the invitation, especially for Mr. as head of structural civil engineering in UIN, and also Ms. Vicky, who are inviting me to have his lecture, international lecture. So it's an honor for me to share the knowledge. Okay, so I'm going to deliver the knowledge to you, all the students, so we can have a good discussion. So not only one way discussion, but I hope we have two ways discussion. Okay, so before going to the lecture, I'm going to give you a practical tips. So maybe my lecture will be more advanced for you since you are now maybe third semester or lower, or the newcomer, that's okay. But the important thing is you need to get two questions. Okay, the first one, what is the purpose? And the second one, how to apply. Okay, so when you see or when you hear my lecture, please try to answer this. What is the purpose and how to apply? So I will give you more simple, okay? Not too detailed, but I hope you can understand what's the purpose and how to apply it. Okay? So before going to my lecture, I'm going to ask you how many of you are interested in structural engineering? Please raise your hand. How many of you are interested in structural engineering? Please just keep your raise your hand. That's okay. I just want to know how many of you. Okay, that's good. Yeah. So I hope this lecture will give you a significant impact for your research because we are discussing about how to deal with the resilience. Okay. So if we are going to talk about the resilience, it means that we are not dealing with the in a short period, but in a long period. How to deal, how to make a sustained structure, okay? Not only for the short period, but how to make it in a long period. How to sustain, how to withstand due to the disaster like earthquake or even wind. But today we are talking about the earthquake, okay? Because we have so many earthquakes here in Taiwan, in Indonesia as well, okay? But in Paraguay, we don't have this kind of earthquake. So it's totally different with Taiwan or Indonesia. So we need to share the knowledge, what's going on, okay? Okay, without further ado, I'm going to share my PPT. Okay. Okay, can you see my PPT now? I hope you can see my PPT.
Yes, I can see.
Okay, that's good.
I'm sorry to repeat
Okay.
because we have a moderator, Mr. Mrs. Dia.
Ah,
Yes,
okay, Mr.
we must Mr. Dia first.
Okay, I'm so sorry.
I'm sorry.
So please go ahead and share. Please go ahead.
Thank you.
Okay, thank you.
Yeah.
Thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning. I'm the head of Civil Engineering Study Program, Dr. Fatima and all civil engineering. And anak guru PhD, sorry. My name is Nia. I'm your moderator for today's first discussion in international webinar about structural resilience. And presentation from this Lord is about post-earthquake seismic assessment method for reinforced constructivity in Taiwan. And then part two was earthquakes. And then in the seminar we have some time for question and comment at the end of the presentation. Participant in online or offline, and this means you can share your thoughts and present any relevant example. This is meant to be an interactive discussion, so don't hesitate to contribute with your insight. And then now it's time to hear from our first speaker, Mr. Lord Yustisia. So participants know about Mr. Lord Yustisia from PhD, complete structural engineering from ITS, and his master's studies and his doctoral studies at National Taiwan University of Science and Technology. And then his research area about hybrid physics and for the rapid post-earthquake assessment and damage assessment of reinforced concrete structure. And now he is assistant professor at National Taiwan University of Science and Technology with strong motivation for continuous learning and academic excellence. Okay, for your time, please join me in welcoming Mr. Lord Yustisia for PhD. The time is yours.
Okay, thank you so much. Yeah, thank you so much, Mr. I apologize for my mistake. So thank you.
Okay, I apologize too. Thank you.
Yeah, thank you for the introduction. So, okay, as you can see in my title of my PPT is post-earthquake seismic assessment method for reinforced concrete buildings in Taiwan. So I'm going to show you the first part is the post-earthquake seismic assessment. So how we assess the seismic after the seismic happens. Okay? So we talk about the existing building or existing structures after the earthquake. And now I'm going to share with you the example in Taiwan because I have learned so much things in Taiwan related to the earthquake. So how we design, how we assess the earthquake, especially for the post-earthquake seismic assessment. So hopefully these topics will get you more deeper, and if you have any questions, please let me know. As Ms. Pia mentioned, I will have two parts. The first part, I'm going to talk about how to do with the simplified method. Okay, so how to use simplified methods for evaluating the earthquake damaged RC buildings. And then the second part, I'm going to the post-earthquake seismic assessment method for the RC buildings in Taiwan. So the first part, it's mainly talk about how the simplified method can be used to evaluate. Okay, without further ado, so this PPT just the introduction, and then going to literature review, methodology, case study, and conclusion. So please, if you have any questions, please just let me know. Okay. Okay, let's go into the first topic. So we need to know the motivation and the background of this topic. Okay. So our target is earthquake damaged RC buildings, which is the buildings that already collapsed or has been damaged by the earthquake. It means that the residual capacity of the buildings will be degraded or will be damaged, will be lower than the new one, than the initial one. Okay, that's the goal. That's the purpose of these topics, to evaluate how the residual capacity of the existing building after the earthquake. Then you will find out. You can use finite element methods, you name it, EFEPS, SAP 2000, even Abacus or ANSYS, to evaluate this kind of buildings. But you may figure out, oh, this very time consuming. Okay, this needs large computational workload, and this is very, very time consuming. Believe me, if you have, or if you already tried to design or model a building, especially a high-rise building, more than 15 floors, yeah, then you use effects or SAP 2000 to design or check the building, and you do with the time history analysis. Believe me, it's really time consuming. So that's why we need a simplified model to reduce the time, to reduce the iteration procedure, okay? To get more effective, to get more optimized, than to guide the engineer to have the best evaluation. So that's why this is the biggest why. Effects, set 2000, so on. That's very time consuming. So that's why we need simplified model to reduce the time, to reduce the iteration, and to have more effective. So that's why. So that's the introduction. So I have two models here, okay? So the left side is the original model. That's the common model. Okay, you can say the original model. And I'm going to show you the two simplified models. So it's called spin model and MLM model. Okay, so for the spin model, it can be used for the high-rise building. And for the MLM model, it can be used for the low or mid-rise building. So with these two models, simplified models, we can do the seismic performance assessment. Okay, let's go jump into the first model, spin model. Okay, so spin model, I'd like to introduce you the parameter of the spin model. First one, we have the screen boundary conditions. So let's take a look on this figure. So we have the special moment frame here. So let's say we have 5 floors. Then you can take in the middle of the special moment frame, you can take one as the representative of the spin model. Then you need to do is calculate the elastic stiffness. Okay? So the elastic stiffness is used to represent the equivalent stiffness of the original building. Okay? So it can be calculated by assuming that we have simple end-to-end beam with the inflection point at the midpoint. Then we simplify it by getting half of the length of the beam. Then you can calculate the elastic stiffness according to this equation, and you have the theta here. So the theta means the factor, the modification factor, according to the configuration of the field. Okay, so we have the elastic modulus, we have the beam width, floor thickness, beam depth, and so on. Then you can calculate according to this equation to get the elastic stiffness. So first thing first, you need to calculate the elastic stiffness. Okay? Then load assign. So after you design, or after you define the spring boundary condition, you need to assign the load. So it's simply as, so this is the original model. So the column axial load, that load, and the right load of the original model will be converted into a concentrate load and given to the beam column joint. So this red arrow represents the concentrated load of the dead load plus the live load. So you can calculate the equivalent load according to the dead load and the live load, and then put at the beam column joint at each floor. Okay. So from the original model to get this simplified model, so you can just convert all the load, the axial load, yeah, especially the axial load, that's the vertical load, from the original model to the simplified model. Okay, then you need to do the plastic hinge. So what is the plastic hinge? So plastic hinge means that the mechanical properties of the damaged RC buildings. Since we have the damaged member, which means that the capacity of the member will be lower, will be reduced according to the original one. So it's lower, okay? But just keep in mind, when you have a damaged member, this capacity will be lower than the original one or the initial one. Okay? Just keep in mind. Because this principle is really important to check or to modify the plastic hinge. Okay? So we have column member and beam member. So in column, you will have plastic hinge of moment and plastic hinge of shear. So this is the represent of the column hinge. Okay, so the hinge will be put on the column, and this represents the beam plastic hinge on the beam. Okay, so after you assign the plastic hinge, so I'm going to show you the detail of the plastic hinge. So according to the April 2019, from the original plastic hinge, which is the black line, okay, the black line will be reduced to the blue line by the reduction factor, okay? So from the original one to the reduced one by the modification factor. So according to this research from April 2019, they have conducted an experiment related to the column experiment, and they have the shaking table to do to simulate the earthquake, and they investigate the modification factor, the reduction factor, according to the damage level. So 1, which is the lowest one, okay, and up to 5, that's the highest one or the severe one. So level 1 means just slight damage, and then going increasing to the 5, that's collapse, which means no residual capacity. If your building is collapsed, it means that your building won't have the capacity anymore. Okay, just keep in mind. So we use this reduction factor to modify the original plastic hinge. Okay, so here's the equation how to calculate the reduced plastic hinge of the damaged member. Okay, then that's for the column, for the flexure, and now this is for the shear flexure. Oh yeah. So for the flexure, they will have a constant line, which is that we hope our building will have a flexure failure at the end. So commonly, okay, so that's the principle. If you want to design a building, please design it in a flexure failure. Don't be shear failure. Please don't design your building to have shear failure. That's nightmare. Okay, don't design like that. So I'm going to show you how to modify the shear failure, or no, this is the shear plastic hinge, okay, over the column. So the same procedure, we use the modification factor, the reduction factor, to reduce the original one from the original curve to the modified curve. So we use this modification factor according to the UFO 2019. So the reduction factor of the column member can be used for the dynamic loading. So it means that earthquake is including earthquake. So that's for the classic hinge. And for the beam, for the original model, so we have the moment at the end of the beam. Okay? So we cut it at the midpoint of the length. Then, like the simplified model, then the moment will have double. Okay? So that's why we have double moment in this point. Okay, just let you know the principle of the simplified model. Then I'm going to introduce you about the second simplified method. It's called NLM. Okay, so it's modified equivalent linearization method in NLM. So yeah, I and my professor developed this simplified model since I was a master student in 2017, and we were working together developing the simplified method. So MELM, that's our first simplified model. Then speed model, that's our second method. So in this method, you will find three regions here: spectral oscillation, velocity, displacement. So, what is the purpose of the MELM? The first one, you can use MELM to calculate or to estimate the response of the structure in terms of displacement. Okay? So you can use this to calculate the displacement response. So using these equations. Okay? So in this case, we will have two kinds of earthquake, which is near fault and far fault. So what's the difference? So for near fault, they have a short range of distance, like the epicenter distance. So it's like a shallow earthquake, and it has more powerful than the far fault. So as you recognize, maybe this year I think in Indonesia, we have several earthquakes, and I think one of them are near fault because the epicenter is shallow. It's shallow near the surface, so that's called the near fault. So that's why near fault is more damaging, and they have severe damage, really bad. So that's why nowadays research are very interested to the near fault. So if you have some interest, please just go in deeper to the near fault. I recommend you. Yeah. Okay, so let's go back to this. So you can evaluate the displacement using the NLM. Okay. So how to use this? So first one, you need to convert from the original model, which is from multi-degree of freedom, okay, MDOF, to the single degree of freedom, equivalent single degree of freedom. How to convert? So you can use this equation So this is the model participation factor. So that's the factor of the first mold shape of the original model. Okay. So you can use this equation to convert from the MDOF to the single nuclear grid in terms of the height of the structure. Okay. Then this is for the plastic hinge parameter for the RC column. So this is based on the Taiwan seismic design code. So this is based on Taiwan seismic design code. Okay. So we have the counterflexural failure here. So it means that we assume double curvature and then have the inflection at mid-height. So we can calculate the flexural failure using this equation, so it's moment strength to the clear height of the column. Then, for the shear failure, if we are talking about a shear failure, it means that we have two participants here, concrete and steel, okay, or reinforcement. So for the concrete or VC, okay, so the concrete will depend on the actual force and the gross area of the cross section and the compressive strength of the concrete. Okay, just keep in mind, okay. So for the VC will be depend on the compressive strength and then the area, the cross area of the cross section, and then the actual force. That's the main factor how to calculate the shear strength contributed by the concrete. Then we have the steel, the reinforcement. So for the reinforcement, they will have this one, Vs, okay? So what's the influencing factor? So the first one is the cross-sectional area of the transfer reinforcement. So it's like sangkang, okay? Transfer reinforcement is sangkang. In spacing S, so the spacing of sangkang will influence the Vs, okay? And also the effective depth. So that's really important. Then you can calculate the VC and the Vs, then you can get a Vn. Later I will show you how to define if the Vm larger than the Vn or Vn larger than the Vn. So in the later PPT, okay? So this is just the literature review, okay? So if the Vm lower than the Vn, you will have flexural shear or structural shear failure, okay? So flexural failure or flexural shear failure. So that's why in our design, we prefer to have this condition, okay, called flexural failure. Why? Because if you see this figure, okay, so this is the plot between the V, the strength, and the displacement. So the strength and the displacement. So it means that we still have displacement capacity up to at a certain point, then this strength will decrease or reduce. So it means that our building or our member still have a certain amount of capacity in terms of displacement capacity before they collapse. Okay, so that's the principle. If we design a building or a member, please design according to the pressure failure or pressure shear failure, because this member still have capacity to withstand or to uh, to withstand the, the displacement. So we still have time to save ourselves or to get or to do the evacuation. So in Taiwan Seismic Design Code, we have some guidance to define the points. So we have 4 points, A, B, C, D. So the A, B, C, D will represent the points according to the strength and the displacement. Okay? So point A is 0, 0, 0. So it's starting from 0, 0. And then point B, we have the yield displacement and the maximum Vm. This is the fracture strength. Okay, how to define the yield displacement is using this equation. K3 means the stiffness of the column. Okay, so after point D, we move for point C. So point C means we have much displacement instead of strength. Because the strength is totally constant, we have the Vm, but the displacement we have higher, we have larger displacement. So we can calculate the delta Fs here using this equation. So it's more complicated calculations, but you need to know if the point C will define how much or how large the displacement capacity of the member. And then after the point C, then I'm going to point D. So point D means that we have higher displacement, but no longer strength. It means that 0, Pm will be 0. So that's the final displacement. So that's why if you see, okay, we can compare to the shear failure. Let's take a look at the shear failure, okay? So shear failure happens when the Vm larger than the Vm. Okay? So let's take a look at the point B. So the point B is the delta S, which means the shear displacement, and the Vm, which means that the shear strength. Then what happens after the point B? The strength is going down so much. Okay? So they don't have to maintain or to withstand the load. So that's why they reduce, or they're going down suddenly. And then up to point C, we will get the final displacement of the shear. So that's why it's, yeah, I'm going to say, if you have the shear failure in your building, it's not so good. So, because shear failure doesn't give us enough time to save ourselves to do the evacuation, because this situation will be suddenly collapse. So that's very dangerous if you have shear failure. Okay, so please avoid this shear failure in your design. Okay, then we move to the beam. Okay, so for the beam, I think just straightforward. We can reduce the stiffness after cracking. Okay, it's a 0.35, so it's a 35% because we assume that after the concrete is cracked or damaged, the capacity will be reduced. So we can reduce the stiffness. And for the moment strength, as I mentioned before, for the moment, we have the positive and the negative moment strength. So they are not equal. So we have to check one by one. And for the shear strength, it's similar with the previous one for the PC and the PS, and then we get the PN. So this is how we define the plastic hinge of RC pin. Okay, so we have more points here, 5 points, and according to the Taiwan SB design code, we can just define the ABC according to this condition. Okay, so we need to calculate the row. So this is the row according to the cross-sectional area and the depth and also the width of the beam, and also the shear reinforcement. Okay, so it's rho accent is the shear reinforcement. So the rho is the longitudinal reinforcement. So you need to calculate this according to the rule balance. And then after this, you can check the conditions to get the small letter A, small letter B, and C. So that's how we define the plastic hinge parameter of the RCP. So how to do it? So that's the big question. So here's the methodology. So I define into 2 parts here. So the spin model on the left side and the annual model on the left hand side. So let's take a look at the spin model first. Okay. So build a spin model with the required parameter. As we learned before, you need to define the spring, the boundary condition, and the concentrated load. Okay. Then you need to assign the nonlinear plastic hinge with a reduction factor, and you need to do the nonlinear dynamic analysis. So nonlinear dynamic analysis means that because we are dealing with the earthquake, so we have to do the dynamic analysis. So I prefer to this analysis using time history analysis. Then we can calculate the maximum deformation of the roof. So I just use the maximum deformation of the roof to get the maximum. So that's how the spin model works. And for the NLM, okay, so we have the damage structure. So we already modified the nonlinear properties of the structure. Then we will do the pushover. So pushover analysis means that you push your structure at a certain point, then you will get the performance capacity of your structure inclined with the demand of the earthquake. So at the cross point from the capacity and the demand, that's the goal. Okay, that's how the pushover analysis works. So after pushover, you will get the structure properties in terms of this is the coefficient yield, and then the yield displacement, and then the rotation, yield rotation, and we have the ground motion parameter here. We have the SA means the spectral acceleration, SV means the spectral velocity, SD means the spectral displacement. So according to this input, we can use this to input to the MLM. Then we get the response, activity ratio, then we get the delta max. So that's the MLM works. So yeah, as I mentioned before, you need to catch two answers. The first one is, what is the purpose? So the purpose of this method is to get the estimation, to get the estimation of the structural response. So the second question is how to apply. So I already shared with you how to apply the parameter inside the simplified model. So if you have any questions related to detailed calculation or how to do it, how to deal with this, please let me know. Because since we have limited time here, so we can have discussion through email or through other platform. But please let me know, okay? If you have any questions. Okay, let's move to the study case. So for study case, I have the reference here. So I'm using the research from Kang et al. In 2023. So they have conducted full-scale shaking table experiments on seismic response. So can you imagine? This is a full-scale shaking table. So I think we don't have this kind of experiment. Yeah, because this is the full-scale shaking table. So maybe we don't have the machine or the shaking table to test the peer loading. But as I remember, in Taiwan, we have this one. We have the shaking table and we have the full-scale experiment. So in this case, they apply the ground motion, 1, 2, 3, 4, four kinds of ground motions with the different intensities. Okay? So this is how they install the buildings. Okay? So first one, they fix the foundation. So that's because this is the full scale. So can you imagine how deep the foundation is? So they use the mat foundation. It means that all is poured by concrete. So it's very thick of foundations. Then they have two stages for the specimen. First one, they just set the lower specimen. So 1, 2, 3, 4, 5. So first 5 story, they did first, then they finalize the upper specimen, which is 1, 2, 3, 4, 5 story. So in total, they have 10 story. Okay. So can you imagine in this figure, they have 10 story full scale in shaking table. Wow. So they have this kind of shaking table with a hydraulic jet, rubber cushion, and they have 2 phases. task. So the first phase is freestanding phase. So it means that they use the cast iron plate. So it means that there's no fixed phase because it's really moved. It's a freewheeling boat. And then they try to have another phase, so the phase 2. So they are using the fixed phase. It means that they fix the foundation, the phase. So the first phase, they use the sliding phase, which is there's no fixed phase, and then the second phase they fix the phase. So that's the difference. But for this case, I only use the first phase, okay? Because just for the simplification. So here I'm gonna show you how to apply. Okay, so yeah. So I'm going to show you a very simple way so you can understand how to do it, how to work with this simplified model. Okay, so let's take a look first. So the first one, you need to select the representative column, which is the nearest beside the centroid of the area to build a spin model. Okay, let's take a look at this figure. So if you see this figure, this is a symmetry configuration. Symmetry means in the x direction and in the y direction, there's no irregular section. So it's a symmetry, okay? So we can easily get the centroid of the area. It's around in this area, okay? So you can select the representative column, which is the nearest beside the centroid. So I'm using this column to be the representative column, okay? So that's okay, you can use this column or this column or this column, but note that's too far from the centroid. Okay, let's say use this column. Then you calculate the rotational spring, Rx and Ry. Okay? So, okay, from this figure, after you choose the representative column, so you can calculate the equivalent in each direction. Okay, so for this direction, that should be the L1 plus L2 divided by 2. So that's the equivalent length of this spin. And for this direction, so you can just L5, which is this L5, over the 2. And that's for this direction and this direction. So that's how we get the equivalent length of the beam. Okay? Then after that, yeah, we need to calculate the rotational spring. So at the end of the beam will be installed by the spring. That's the common spring, okay? That's the original spring. Rotational spring, okay? So in each direction, Ry and Rx. Then you need to calculate the stiffness of the spring by using this equation as we mentioned before, okay? Then you need to define the support at the end of the member. So the roller support at the end of the representative beam and fixed support at the first story of the column. So this is the final view of the spin model. So you can see that this speed model consists of equivalent beam and equivalent column. Okay, so that's how to convert from the original one to the equivalent one. Okay, then you need to check the effective stiffness. Okay, so we have the section properties here. So in this case, we have 10th floor. So we have the column section here. We have the strength of the concrete, FC prime. We have the beam section. We have the floor thickness section, and also we have the load properties. So we have the structural component and non-structural component, and we get the total here. So each floor, you need to define the structural component and the non-structural component. Okay? So you can define it according to the dead load and the live load. So for the structural component, you can have the combination about this load. Okay. So we have this kind of information. So then you need to calculate the stiffness of the spring using this equation. So how to do this? So here for the rotational spring. So in this direction, Rx1, okay. So we have the elastic modulus of the beam in each floor. Then we have the moment inertia of the beam, and we have the original length of the beam. Then the important thing is the phi or the phi. Okay, this is the modification factor according to the beam configurations. So we have the exterior L beam corner. Okay, which means this is the exterior L beam corner in the brown color here. That is the exterior L beam corner. And we have the exterior T beam corner here. That's the blue one. So we have member N, and N represents how much the member. So the amount of the member. So we have 2, okay, for the XL beam corner, 2, and also for the T beam also 2. Then you input all these together into this equation to get the effective stiffness of spring. So that's how we calculate the rotational spring. So you need to do it at the other side. So this is for another side for the Rx2. So for the Rx2 we have external L beam middle and internal T beam, interior T beam middle. So that's the difference, okay, between the Rx1 and the Rx2. We have more variation in this direction. Okay, then you need to do it also in the Y direction, so RY1. So you have the exterior L beam and the exterior P beam, like this one. And you do the same procedure for the RY2. Okay, same procedure. You will have the exterior L beam middle, interior T beam middle, and so on. Okay, then you need to calculate the effective stiffness. Then you can assign the load. So as I mentioned before, the combination of the dead load and the live load of the original model will be converted into a concentrated load. Okay, so this is the concentrated load. Just only the concentrated load. No distributed load. Okay, that's because at the model we assume this spin model have just only one representative column. Okay, so we make the concentrated flow and given to the beam conjoint in each flow, like this one. Then how to evaluate the damaged member? So according to the CONF, so they have damaged the building using the shaping table, and they have the result from this. Okay, so they provide the story trip ratio. So story trip ratio means that how much your story will be displayed at a certain point. So in a percent, it means that in the ratio of the height of the story. So we have the story trip ratio here with the different intensity of the Kobe seismic earthquake. Okay, so by using this information and the story trip limits associated with the damage level according to the FEMA and the CL. So in this case, we use the ductile moment resistant frame here. Okay, so this is the state of damage. So we need to check how much the drift ratio here according to the Kangaroo model. So refer to this information, then we can get the damage level of each story. Okay, so let's try again. Let's say it again. So from this information of story to ratio in each story, then using these limits provided by the FEMA, so they have the limits associated with the various damage level, then we can define each floor has the damage, which damage or which level of the damage. So we can define all the member, all the floors in terms of the column in the beam in the different intensity of the Kobe. Okay. So this information can be called as the damage members information here. Okay. Then we need to assign the plastic hinge. As we discussed before, you can just define point A, B, C, and D. So this is for the pressure failure, and A, B, C for the shear failure. Okay. So you can do it on in every. Okay. Then for the beam, you can just define according to the point A, B, C, D up to F using the table that I already mentioned to you. But for the beam shear failure, spin model doesn't assign beam shear hinges. So this is one of the limitation of the spin model. So right now, spin model doesn't have this kind of configuration. So that's for the limitation of this model. Then we move to the MEI model. So how to convert to the single degree of freedom? So from the original model, let's say 28.5 meters, the total height of the building. Then we need to check the equivalent height of the building. So using this equation, okay, so you can check in each story about the height and the mass and the first motion. So you can use this information to get the equivalent height of the building. But you can assume or you can estimate to have 2/3 of the original model height. So according to the UIN 2020. Then you can use the input for the MLM. So in this case, you can input the SASV and SD here, and then the CY to calculate the delta Y and the mu itself to get the maximum displacement. So the comparison, it means that, so this is the comparison according to the natural period and the maximum deformation, okay? So if we, it means that the spin model and the MLM can have a good agreement to the original model, because if we compare to this, to the original model, they have slightly error, but for the MLM, maybe it's not so good, because MLM is used for the low-rise building, so still have limitation for the MLM. Yeah, so for the conclusion, so we already learned about how to use the simplified model. So the simplified model is used to estimate the maximum deformations of the damaged RC building. So according to the result, MLM provides more underestimation because MLM is used for the low-rise building, because the case study is high-rise building, is more than, it's 10 floor building, and MLM can provide a rapid estimation, so the engineers can use this method for the preliminary stage. So it's very helpful if you want to use the MLM to just check your design in the preliminary stage. Okay, then you can use the spin model to go in deeper, going more detail, and then to build because the spin model will have the conservative result according to the linear data analysis. So I hope you can grab the knowledge for the lecture today. So I will open for the Q&A session. So I will give to Miss Tia as the moderator. So please, time is yours.
Oke, silakan disiapkan pertanyaan. Sudah ada pertanyaan? Sudah ada yang menyiapkan? Okay, next, this is time for question and answer session. Oh ya, di sini ada yang tanya.
Ya, boleh saya tanya kalau ada pertanyaan.
Pakai bahasa Indonesia juga, Boy ya?
Siap. Maaf tadi saya full bahasa Inggris.
It's okay.
Nanti kedepannya mungkin lebih bilingual ya, kalau ya, kamu silakan.
Bahasa Jawa ya. Mas Lordi aja manggilnya bukan Pak ya.
Iya, boleh saya panggil Mas Lordi, boleh. Ini dari Surabaya, Pak.
Surabaya. Makanya diajak bahasa Jawa tuh. Boleh tuh tanya bahasa Jawa.
Monggo silakan.
Ya, silakan anak yang mau tanya. Di-trigger Pak Fikri dulu mungkin kan. Yang di Zoom juga boleh loh. Tanya-tanya bisa lewat chat.
Ini sudah ada yang mau tanya? Pak, speakernya pakai yang mana sih? Speakernya pakai yang mana? Ini sudah ada yang mau tanya Bu dari sini.
Oh iya, boleh, silakan.
Silakan. Disebutkan namanya dulu Mas, sama semester angkatan.
Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Muhammad Mustafa dari angkatan 2024. Ini pertanyaannya pakai bahasa Inggris atau bahasa Indonesia?
Bahasa Jawa boleh, silakan.
Pertanyaan ini terkait apa pentingnya memberikan gerakan tanah Northfield and Southfield dalam perencanaan tanah gempa? Itu Mister.
Atau boleh moderator dibantu catat pertanyaannya.
Saya ulangi untuk pertanyaan saya, yaitu what is the importance of comparing earthquake and earthquake on Martian in seismic design?
Oke. Oke, boleh. Saya tampung dulu, ada lagi yang mau bertanya?
Thank you Mr. Mas Esi. Assalamualaikum warahmatullahi wabarakatuh.
Ya, salam.
Baik, selanjutnya barangkali partisipan yang dari Surabaya, UIN Surabaya, ada yang mau tanya, silakan raise your hand.
Atau dimulai tadi, siapa yang tertarik pada struktur tadi? Tadi kayaknya banyak tadi yang tertarik pada struktur tadi. Boleh sekali angkat tangan?
Yang tadi angkat tangan, yang tertarik sama struktur, boleh? Angkat tangan lagi.
Boleh nggak? Oke. Boleh deh salah satu dari kalian tanya. Ayo. Pak Vicky boleh bantu pilih. Boleh.
Mau bertanya di luar topik juga boleh ya Mister ya?
Yang 2024 ya, 2025 ya.
Tanya-tanya boleh sahabat, boleh tanya-tanya sampai di sana gimana juga nggak apa-apa ya.
Iya, boleh.
Oke, ini ada the next question.
Di para pegawai di sini gimana?
Udah berapa tahun di pada gue?
Oh, saya baru 3 bulan Bu di sini. Dari Agustus kemarin, ya.
Karena awalnya di Taiwan tadi postdoc atau?
Ya, saya postdoc di Taiwan 2 tahun. Dari Juli kemarin sudah selesai, terus pindah ke Paraguay kebetulan. NDST itu ada buka kerjasama sama Paraguay. Jadi buka ini Jadi pemerintah Taiwan dengan pemerintah Paraguay itu ada kolaborasi di bidang pendidikan. Jadi Taiwan ingin memajukan pendidikan Paraguay, jadi menunjuk NGSP sebagai partner kolaborasi untuk membangun universitas di sini, yaitu UITP, Universidad Politeknik Taiwan Paraguay. Jadi mereka membutuhkan tenaga pengajar, jadi semua profesor, beberapa profesor dari NGSP dikirim ke sini. Ya.
Next nanti boleh dong dengan UIN Malang juga.
Boleh. Nah kalau misalkan teman-teman ini ada yang tertarik, mungkin kan masih semester 3 ya kalau nggak salah ya, masih awal-awal kan? Ya nggak apa-apa. Ini kan jadikan ini sebagai satu kesempatan untuk mencari tahu ternyata seperti ini ya kehidupan penelitian seperti ini sekarang. Jadi ke depan punya rencana kira-kira setelah lulus mau ngapain ya? Salah satunya join ke akademik misalkan.
Jadi udah punya target ya, apalagi kalau sudah ada kayak partner seperti ini lebih jelas tujuannya kemana gitu kan ya?
Ya, nah.
Ya Bu ini ada lagi yang bertanya
Ya,
atau yang
ini
bisa
the
dijawab?
second question, silakan.
Baik, terima kasih
Ya, saya
atas.
jawab dulu aja ya.
Iya.
Sambil nunggu yang lain ya.
Ya.
Oke.
Terima kasih atas.
Pertanyaannya.
Iya.
Jadi yang saya dapat tadi pertanyaan tentang pergerakan tanah ya, efeknya ke proses desain. Nah, seperti yang kita bahas tadi, kita bisa identifikasi khususnya pergerakan tanah, yaitu kalau misalnya pergerakan tanah ini lebih dekat dengan permukaan tanah, kita bisa jalan near fault atau near field, sehingga near fault ini punya karakteristik yang lebih damaging atau lebih rusak, jadi lebih punya dampak yang berat gitu, terhadap struktur ya, dibanding dengan faktor tadi. Nah, setiap pergerakan tanah ini punya ciri khas atau karakteristik yang mempengaruhi seismic design, yaitu dengan memasukkan faktor-faktor seperti faktor koreksi tanah atau faktor koreksi intensitas dari seismiknya sendiri. Jadi itu banyak sekali faktor yang diperhatikan sebelum kita masuk ke seismic design tadi. Jadi yang perlu digarisbawahi adalah kita perlu tahu bagaimana si pergerakan tanah atau faktor-faktor yang mempengaruhi ini, sehingga kita bisa tahu kapan dipakainya di seismic design itu tadi. Kayak gitu. Kira-kira sudah menjawab pertanyaannya? Tadi siapa tadi namanya? Ibu ini? Siapa tadi namanya?
Akil bisa. Gimana, sudah terjawab? Mas Akil? Oh, sudah.
Pertanyaannya boleh agak putus-putus boleh.
Ya, tadi yang bertanya atas nama Akil, Mister, sudah terjawab.
Karena ini kemir. Wah ini kemir.
Ya, tadi yang pertama bertanya atas nama Akil, sudah terjawab katanya, Mister. Selanjutnya ini ada pertanyaan kedua dari Cheryl. Ya, kami persilahkan.
Karena dari sini langsung. Iya.
Baik, terima kasih atas waktunya. Saya Yustisia.Bermanfaat dari angkatan 2024. Izin bertanya, mengapa metode MILM menghasilkan informasi yang lebih rendah dibandingkan spin model? Terima kasih, Mister.
Ya. Dengan siapa tadi?
Cheryl.
Oke. Ya, terima kasih Cheryl untuk pertanyaannya. Ya, bagus sekali pertanyaannya. Kenapa MLM lebih ini ya, lebih ringkas gitu ya, lebih sederhana gitu ya dibanding screen model ya. Baik, karena pada awalnya MLM ini dikembangkan untuk single degree of freedom. Jadi cuma satu model perkakuan. Jadi kita mengasumsi sebuah struktur dari yang original, yang multi degree of freedom tadi, ke single degree of freedom, which is itu banyak mereduksi kekakuan, banyak mereduksi bagian-bagian yang dari yang tadi, sehingga MLM itu punya input parameter yang lebih simple. Kita cuma masukin ke motion parameternya, kemudian masukin dari CY-nya atau RY-nya tadi, jadi hasilnya juga lebih simple. Makanya kenapa hasil dari MLM bisa dibilang kurang akurat untuk mendekati ke originalnya, karena itu tadi terlalu banyak mereduksi poin kekakuannya tadi. Jadi hasilnya tidak terlalu bagus, tapi MLM lebih cocok untuk yang bangunan rendah seperti 2 lantai rumah atau 3 lantai. Jadi kalau lebih cepat untuk mengestimasi respon strukturnya itu tadi. Seperti itu kurang lebih. Semoga menjawab Shadow ya.
Gimana? Syaril sudah terjawab? Sudah terjawab ya? Oke, baik. Ada yang mau tanya lagi nggak?
Ayo, Bapak tanya, kok bisa ke sana gimana Pak caranya? Ada yang pengen ke luar negeri?
Gimana? Caranya gimana?
Oke, ini ada pertanyaan ketiga.
Kita ada yang bertanya di chat buat Ari.
Oh iya,
Oke.
mau dijawab dulu Mister yang di Zoom ada yang bertanya melalui chat.
Sebagai silakan.
Mau ditanya dulu atau mau dijawab dulu atau kita langsung dulu?
Oke, saya bisa jawab dulu yang di chat. Ini saya bacakan ya. Jadi bertanya, bagaimana cara agar menjadi ahli atau expert di bidang struktur dan sipil, serta apa saja bekal dan hal-hal yang harus dipelajari mulai dari dasar-dasar dan lain, serta apakah industri struktur sendiri bisa menjadi industri masa depan. Ini sepertinya yang tanya sangat visioner sekali ya, sudah memikirkan masa depan. Sangat bagus pertanyaannya. Oke, saya jawab. Yang pertama, bagaimana cara menjadi ahli? Yang pasti belajar, itu sudah pasti. Sekalipun saya di bidang akademik dan mungkin teman-teman yang lain mungkin atau punya kenalan yang lain di bidang yang lain, kontraktor dan sekalipun, kita tetap belajar, kita terus belajar, kita terus memperbaharui pengetahuan kita terus mempelajari, bahkan sharing knowledge kita sharing experience kita ke beberapa expert atau ke beberapa profesor. Makanya itu yang pertama, kemampuan belajar kita jangan sampai hilang. Itu yang jadi dasar di antara dasar-dasar yang lain gitu. Kalau sampai kemampuan belajar kita hilang, udah nggak ada harapan lagi gitu sudah. Jadi kemampuan belajar itu harus ada. Jadi terus kalau secara teknis hal yang harus dipelajari ya pasti mata kuliah dasar. Yang pasti ya mekanika teknik tertentu segala macam. Mata kuliah dasar itu harus dikuasai. Karena apa? Karena itu akan menjadi fondasi kita sebelum kita merancang atau mendesain suatu struktur. Karena kita harus tahu pola pikirnya dulu, kita harus tahu mekanismenya, struktur ini bagaimana, bila terkena gempa atau terkena beban. Jadi kita harus tahu mekanismenya dulu, seperti itu. Jadi, nah, terus setelah itu kita juga perlu tahu teknik atau karena kita kan nggak cuma belajar tentang apa yang harus kita kuasai, tapi kita harus belajar tentang manajemen juga. Nah ini penting banget, ya saya juga belajar sih. Manajemen itu sangat penting ya, karena kita bekerja dengan orang, kita teamwork, satu tim, kita nggak bisa sendirian kerjanya. Ya sama lah, kalau kalian kerjain tugas atau apalah yang butuh tim, kan nggak mungkin ada satu orang yang ngerjain semuanya gitu kan. Tapi nggak tahu ya, mungkin kalian ada, tapi please jangan ngelakuin itu. Kita harus bisa kerja tim, jadi kita harus bisa manajemen. Terus industri struktur akan menjadi industri masa depan, yes, pasti. Karena dunia kita terus bertumbuh, berkembang, akan ada banyak industri perkembangan di depan, khususnya pertumbuhan infrastruktur. Karena setiap negara, setiap wilayah kita butuh infrastruktur. Di mana infrastruktur itu ada, di situ ada teknik sipil. Jadi percayalah, kita berada di jalan yang tepat di teknik sipil. Oke, kalau teman-teman merasa ini bukan jalannya, ya coba dipikirin lagi. Oke, saya berani jamin kita semua berada di jalan yang tepat. Di teknik sipil, karena teknik sipil akan terus berjalan, akan terus dibutuhkan di masa depan. Mungkin itu aja sih yang bisa saya sharekan untuk pertanyaan ini. Mungkin saya terjawab ya, Maulana. Semoga bisa terjawab.
Oke, terima kasih. Selanjutnya ini ada pertanyaan terakhir dari mahasiswa Teknik Sipil UIN. Silakan.
Assalamualaikum warahmatullahi wabarakatuh. Sebelumnya perkenalkan, nama saya Muhammad Yustisia.Bermanfaat. Saya dari angkatan 25 Teknik Sipil Malang. Di sini saya ingin bertanya tentang apa sih arti penggunaan RC atau reinforced concrete yang sudah disebutkan tadi. Jadi kan tadi sudah disebutkan, sudah dijelaskan, tapi dalam bahasa Inggris. Mungkin teman-teman ada yang kurang paham, jadi mungkin bisa diulangi dalam bahasa Indonesia. Dan satu lagi tentang bagaimana cara, mungkin ada teman-teman yang ingin melanjutkan studi ke luar negeri juga. Jadi sebagai langkah-langkahnya atau bagaimana tips and triknya. Itu saja, sekian dari saya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Ya, saya jawab langsung ya. Ini. Oke, terima kasih Muhammad ya, angkatan 2025. Untuk pertanyaan pertama, reinforced concrete yang terdampak, karena fokus kita hari ini itu adalah mengevaluasi struktur terdampak gempa. Jadi struktur itu sudah rusak oleh gempa, bisa jadi sudah kolaps, bisa jadi cuman rusak sedikit, rusak parah. Nah, bagaimana cara mengevaluasinya? Yang pertama kita harus tahu dulu seberapa rusak ini bangunan. Oke, karena itu menentukan level kerusakan dari bangunan itu. Caranya gimana? Tadi saya sudah menyampaikan bahwa dari case tadi yang saya sampaikan tadi, dari story grid, oke, kita bisa tahu berapa di setiap lantai story tripnya, kemudian dicocokin dengan batasan yang disampaikan oleh Firman tadi, bahwa sekian limit itu level 1, sekian limit level 2. Nah, dari informasi ini kita bisa mendefinisikan setiap level kerusakan. Jadi itu tadi RC damage structure itu adalah bagaimana kita bisa mengevaluasi struktur yang sudah rusak karena itu. Oke, itu pertanyaan pertama. Kemudian untuk pertanyaan kedua, bagaimana cara melanjutkan studi ke luar negeri? Oke. Yang pertama, pastikan teman-teman punya keinginan itu. Oke, harus kuat, benar. Kalau nggak kuat, mending nggak usah sekalian. Kita harus benar-benar serius. Karena studi ke luar negeri bukan main-main, butuh persiapan yang matang, yang pasti butuh biaya. Oke. Jadi kalau teman-teman nggak serius, mending jangan. Caranya gimana? Cari scholarship. Kalau teman-teman nggak kendala dengan biaya, cari beasiswa. Banyak beasiswa yang sudah disampaikan pemerintah, baik itu dari pemerintah maupun dari universitas yang bersangkutan. Nah, saya referensikan ke Taiwan. Jadi berdasarkan informasi atau pengalaman saya sebelumnya. Jadi saya datang ke Taiwan 2017 S2. Itu saya apply itu beasiswa dari DST. Saya cari-cari di webnya DST di bagian scholarship. Itu pasti ada. Setiap tahun, setiap semester ya pasti ada. Itu pasti buka. Nah, dicek tuh kriterianya apa, terus requirement-nya apa yang harus disampaikan. Kemudian biasanya itu nilai-nilai atau transkrip bachelor, ada 1. Terus kalau mungkin ada pernah nulis proposal penelitian atau pernah public paper, mungkin itu akan lebih bagus. Tapi kalau nggak ada, tidak apa-apa biasanya. Ya udah, dilengkapin aja itu semua requirement-nya. Setelah itu, ya udah cari beasiswa yang memungkinkan untuk bisa didapatkan. Dari pemerintah juga, ya kebetulan saya dapat yang dari pemerintah ini waktu saya S3 dari DST. Jadi kalau kita punya keinginan yang kuat, pasti keinginan itu akan membukakan jalan gitu. Jadi kalau kita nggak punya keinginan kuat atau ragu untuk belajar ke luar negeri, mending nggak usah sekalian. Gitu sih. Itu yang bisa saya jawab untuk pertanyaannya dari Muhammad. Semoga membantu, memberi sedikit pencerahan. Ya.
Oke, baik. Baik, terima kasih Mister. Selanjutnya ada pertanyaan lagi dari kolom chat Zoom dari Umirsa. Sebelumnya kepada Bu Dia selaku moderator, barangkali mau membacakan pertanyaannya, kami persilahkan.
Oke, terima kasih. Tadi bilang sinyalnya ya. Ini ada pertanyaan dari Ibu Eva Suryani. Apakah selain model memberikan hasil yang lebih efisien dari segi komputasi dibandingkan time story 2? Apakah MLM dijadikan alternatif untuk mempercepat proses desain tanpa mengorbankan ketepatan hasil analisis dinamis? Terima kasih.
Ya, terima kasih Bu Eva atas pertanyaannya. Ya, sangat bagus sekali. Yang pertama, apakah speed model memberikan hasil yang lebih efisien dari segi komputasi dibanding time story? Ya, saya berani berkata dia lebih efisien. Bahkan dibanding time story, dia bisa 10 kali lebih cepat. Kalau misalkan time story kita biasa running satu model misalkan 10 jam ya. Saya pernah sih ada 10 jam untuk satu time history analysis. Dan ini kita bisa 10 kali lebih cepat, mungkin cuma 1 jam, 1,5 jam. Dengan hasil yang mendekati dengan time history. Jadi ini sangat-sangat efisien untuk mempersingkat waktu, khususnya untuk iterasi ya, karena ya time history itu sangat-sangat time consuming ya, jadi sangat butuh waktu. Kemudian yang kedua, apakah MLM dijadikan alternatif untuk mempercepat proses desain tanpa mengorbankan ketepatan hasil analisis dinamik? Ya, bisa. Seperti yang saya bilang tadi, MLM punya batasan, tidak sebagus spin model. Kenapa? Karena MLM mengasumsi satu struktur itu sebuah equivalensi single equilibrium. Jadi yang dari semula multi equilibrium, kita reduce, kita turunkan menjadi single equilibrium. Sehingga dari proses penurunan ini, banyak sekali hal-hal yang direduksi. Mengakibatkan hasilnya tidak seakurat spin model, tapi memberikan hasil yang lebih cepat. Jadi bisa dijadikan sebagai preliminary stage, jadi mungkin bisa menjadi estimasi awal gitu lah ya, sebagai untuk estimasi awal kira-kira respon struktur saya kalau kena gempa seperti ini seperti apa ya, nah gitu. Jadi itu bisa jadi patokan nanti apakah desain saya benar atau salah, seperti itu. Semoga membantu untuk pertanyaannya.
Oke, terima kasih. Itu ada tambahan lagi dari Bu Eva Suryani ya, 10 kali 1 sampai 1,5 jam MLM batasan asumsi stroke SDOF reduksi pre-M. Oke, terima kasih Bu Eva. Thank you for Mr. Rodi Zepajan Grono PhD. Mungkin ada pertanyaan lagi dari partisipan lain, dari mahasiswa? Tidak ada ya? Oke, kalau nggak ada, thank you for your excellent for sharing your knowledge too. Oke, selanjutnya saya kembalikan kepada Ibu Susmiyanto lain. Terima kasih.
Ya, baik, terima kasih Bu Dia. Ya, beri aplaus untuk Bu Dia dan Yustisia.Bermanfaat. Baik, selanjutnya adalah serah terima sertifikat oleh Akademi Teknik Sipil UIN Malang kepada narasumber kita, Mr. Lordi Zevania. Kepada Ibu Tanita, kami persilahkan.
Terima kasih Bu Aini. Pak Lordi, kami tidak bisa memberikan apa-apa. Ucapan terima kasih yang sangat besar atas kesediaannya. Meskipun di sana jam 10 malam ya, waktunya istirahat, tapi alhamdulillah Pak Lordi bersedia untuk berkenanlah untuk hadir pada pagi hari ini dengan memberikan insight knowledge yang sangat berharga buat semuanya. Juga ada sertifikat dari kami, semoga bisa bermanfaat untuk Pak Lordi. Terima kasih banyak atas kesediaannya sekali lagi.
Ya, sama-sama Bu Tara dan segenap sivitas Teknik Sipil UIN, saya mengucapkan terima kasih atas kesempatannya. Semoga bermanfaat untuk Anda.
Amin, amin.
Yeah. Okay. Thank you very much, Mr. Lordi Zevania, for your insightful and inspiring presentation. But before ending this session, maybe take photo together, Mr.
Yeah.
Okay. For all participants, please turn on your camera. Oke, saya hitung dalam hitungan 3 detik. Silakan yang belum menyalakan kamera untuk menyalakan kamera terlebih dahulu untuk kami ambil dokumentasi. Sudah siap? Sudah siap? 1, 2, 3. Oh belum, masih ada kesalahan teknis. Oke, saya ulang lagi.
Videonya nyalain.
Ya, yang belum menyalakan kamera silakan dinyalakan dulu.
Biar kayak di kelas beneran gitu, bisa ngeliat murid-muridnya gitu.
Oke, kita hitung lagi ya. Sudah siap Pak Vicky? Oh iya, kita tunggu untuk yang dari Indonesia untuk menyalakan kamera terlebih dahulu. Oke, mungkin cukup ya. Sudah, kita mulai ya. 1, 2, 3. Lagi. Satu kali lagi. 1, 2, 3. Okay, thank you very much. Give a round of applause. Ya, demikianlah sudah berakhir untuk sesi pertama. Terima kasih mengucapkan kepada Mr. Rodi dan Ibu Dea. Okay, the next agenda, I'd like to invite our dream Cheryl and friends to lead the ice breaking. We give you 15 minutes.
Oke teman-teman, waktunya nyangkai. Ayo, udah ketebak belum? Aku berdiri di sini ngapain? Iza mana Iza? Ini pertama kita main tebak-tebakan biasa. Nanti ditayangkan di TV ya tebak-tebakan. Yang kasih clue nanti pesertanya. Untuk permainan tebak-tebakannya, sebelum tebak-tebakan kita game dulu. Nanti yang maju ke depan kita jelaskan kalau nggak bisa. Jadi ya teman-teman, untuk mencari masanya kita tepuk 1, 2, 3, dan 4. Nah, peraturannya untuk nanti pas tepuk 4 itu nggak boleh ada yang tepuk tangan. Kalau tepuk tangan berarti maju, oke? Semuanya paham? Oke, kita tentukan ya. Tepuk 1. Konsen. Tepuk 1. 1, 2, 3, 1, 4. Paham semuanya? Bisa langsung dicoba? Sudah dapat jajan semuanya? Oke, bisa langsung. Oke, langsung saja kita mulai teman-teman. Jangan lupa fokus. Ayo. 1, 2, 3. Tepuk 1. 1, 2, 1, 2, 3, 2, 1, 2, 3, 4. Ayo maju kakak. Mas Satria. Ayo maju Mas Satria. Ayo Mas Satria maju. Baik lagi ayo. 1, 2, 3. Konsentrasi. Tepuk 1, 2, 3, 1, 2, 3, 2, 1, 4. Ayo Mas Lana, maju Mas Lana. Yang nggak tepuk juga yang maju. Yang nggak tepuk. Teman sampingnya tolong diperhatikan, yang tidak ikut tepuk berarti dia disuruh maju. Semuanya setuju? Oke, 1, 2, 3, fokus. Tepuk 1, 3, 2, 1, 3, 2, 2, 3, 4. Baik, ini teman-teman fokus.
Oke, ice breaking 5 menit lagi ya.
Langsung saja ya kita tebak-tebakan ya, biar tidak mengulur waktu. Dari Pandu, nanti yang ngasih clue teman-teman. Yuk, slide run. Jangan lihat. No.
Tidak satu kali kan setia.
Hewan dulu.
Ya, yuk, kasih clue.
Hewan.
Ayo, Pandu. Ya. Slide dulu nanti. Ini yang jawab.
Barang.
Udah atur.
Kayak gak celawang.
Cepat ya.
Coba skip Rak, gak jawab. Tapi agak lama mana ya? Ayo Lan.
Ayo. Aplikasi.
Beri tepuk tangan semuanya teman-teman. Baik, kita cukupkan untuk sesi briefing kali ini ya teman-teman. Semoga di materi selanjutnya kita dapat mendapat ilmu yang lebih bermanfaat lagi. Amin, amin, ya rabbal alamin. Baik, saya dan rekan saya Mbak Sheryl izin pamit undur diri ya. Wassalamualaikum warahmatullahi wabarakatuh. Okay, thank you, Miss Sheryl. Okay, next we are going to the next session. The presentation for the second keynote speaker, Mr. Hari, DEMC PhD, a project assistant professor from NTUSD Taiwan, and will be moderated by Mr. Hilal Shihabuddin, MT. Please welcome Mr. Big round of applause.
Could somebody hear my voice? Is my voice clear? Mr. Heri Hermawan, can you hear my voice?
Halo, selamat pagi semuanya. Kedengaran nggak suaranya? Oke.
I think no problem with the song. So I will speak myself. My name is Yustisia.Bermanfaat. I'm a lecturer di Islamic University of Malang. Today I will moderate the discussion of the seminar about self-building of concrete. I will introduce our speaker today, Mr. Heri Hermawan. I will call him Mr. Hermawan. He is a lecturer in the NTST University of Taiwan and graduated from the University of KU and UPV of Valencia in Spain with thesis titling Optimized Mix Design for Self-Healing Concrete that is fully funded by European Union under the program of Marie Curie Grant Agreement. Mr. Heri Hermawan is our professor in self-healing of concrete. And today, I think that it will be our topic for
Okay, so thank you for the opportunity. I'm going to share my slides now. Is everything okay? Is it clear for everyone for my presentation?
Yes.
Okay then, so I think I'm going to start my presentation. So, well, first of all, good morning to the students from UIN Malang and also for the lecturers from the UIN Malang. I'm very thankful to be invited here. It has been my privilege and also my honor to be here as a speaker at this international webinar. And also, I'm going to thank Vicky and also Pak Vicky for inviting me to be here as a speaker. And well, in this happy occasion, I'm going to present about my study related about the advancement of the modern construction using the self-healing technology. So my name is Ari Hermawan. I'm a project assistant professor from NTST Taiwan. So this is my outline of my presentation, starting from the autobiography, introduction, self-healing material, engineering properties, conclusions, and lastly, my future perspective. So let's start from the autobiography. Well, I'm going to briefly introduce myself again. So my name is Ari Hermawan. Currently, I'm serving as a project assistant professor at NTST Taiwan. And 2 years ago, I completed my PhD studies at Leuven in Belgium and also Universitat Politecnica de Valencia, which is located in Spain, in Valencia, obtaining the title of a Doctor of Engineering Technology. And previously, I have also obtained the Master of Science degree from the NTST Taiwan, and also I have received the Bachelor of Engineering degree from Parahyangan Catholic University in Indonesia. So prior to my employment now, I also have worked as a research associate at Leuven, Belgium. So far for my publication, I have published around 9 journal articles and also 7 conference proceedings and also book series. So let's go a bit deeper about the self-healing concrete, and I'm going to start with the introduction. So what is the self-healing? Well, self-healing, actually, this concept is derived from our human ability to respond to any flaw or any defects. So you can imagine if you have any scars or any flaws on your human tissue or on your skin, what happens? So if you see, there will be some gradual healing over the time because later it will have such interaction with the blood vessels, and also there will be interaction with the epidermis of our human tissue. So later it will be gradually healed over the time. So this concept of the self-healing, we are going also to try to implement not on our human body, but on construction materials. Okay, so as we know, concrete is the most consumable materials in the world, and concrete can withstand a high compression stress, but concrete itself is relatively weak in tension. And due to the high tensile stress, environmental condition, harsh environment, or any excessive loading, cracks may occur. And cracks starts growing from the micro size into the macro size. And the ingress of the water and harmful liquids into the crack may lead to the concrete degradation by corroding the steel reinforcement, deteriorating the concrete matrix, and lastly, there will be a complete failure. So how actually we try to mitigate this crack formation? So there have been many efforts by main applicators to patch the existing cracks. However, the problem is with this patch crack of the crack, this method is temporary, time-consuming, and also it's relatively costly. So there is a need to heal the cracks in a sustainable way, and this can be done using the self-healing technologies. So let's have a look. What is the main distinction between the traditional concrete or just a normal concrete as compared with the self-healing concrete? So from the name itself, we know that with the self-healing, we can imagine now. We have both cracks on those two specimens. So what's happening on the self-healing concrete? Well, from the name, it's a self-healing concrete, so we will expect there will be a crack closure on this specimen because it's self-healed. But what happens with the traditional concrete? Well, apparently, traditional concrete also possesses a healing activity or a crack closure. Well, so if both have this healing activation, so what are the distinctions? Let's have a look much deeper. So, for the autogenous healing mechanism, this is the mechanism which is derived from the original constituent of the concrete. So, this component promotes the crack healing only under favorable environmental condition and mainly driven by the chemical reaction of the raw materials. So what are some factors that affecting this autogenous healing mechanism, particularly on traditional concrete? So first of all, it's about the clinker content or the cement type. So the clinker content in relation to the cement type, it determines the supply of the calcium ions and subsequently the ability to develop the precipitation products. So if you learn about the cement materials, because cement also there are many types. For instance, Portland cement type 1, type 2, type 3. Even there are some pozzolanic cement. So it depends on which type of this cement that can supply calcium ions. Typically, we will use the Portland cement or the cement type 1 according to the ASTM that will give a high amount of the calcium ions. Next, the silicate addition also determine the autogenous healing. So the silicate addition determines the duration of the healing mechanism due to the characteristic pozzolanic reaction and also how fast they will consume the calcium carbonate, the calcium hydroxide from the hydration product of the cement. The third factor is the aggregate. So may also induce an effect on the cracking pattern, which indirectly influences the healing process. Next is the concrete class. So concrete class may also contribute to the healing effect. So for instance, if you are having or designing a high strength concrete with a low water to cement ratio, it will contain a generous amount of the unhydrated cement particle that can later develop or grow a sufficient amount of the calcium silicate hydrate, calcium hydroxide, and also ethylene as a result from the ongoing hydration. So this determines basically the healing effect. And lastly, it's about the concrete age. So concrete age is also very important with respect to the healing mechanism. Because of what? Because for the concrete at the young age, let's say concrete are at the age of 7 days or 14 days, they contain also unhydrated cement in the binder system. And later they will develop new tobomorite gel or calcium silicate hydrate gel as a result from the ongoing hydration. But with the old concrete, most of the portion from the cement particle they have been hydrated, so they need also some calcium from the other source in order to let the autogenous healing works. So these 5 factors are the main factors affecting the autogenous healing mechanism derived or from the traditional concrete. Then, with the autogenous healing mechanism, here with on the traditional concrete, there are several causes. So if you look here from the left hand side, there will be a physical cause, and this physical cause is due to the swelling process. So concrete in general, it will either shrink or it will swell. So if your matrix, when you design your concrete concrete mixture, if your concrete is designed to swell, so the swelling of the matrix or the material will also later lead to the crack closure. Next, with regards to the chemical cause, the autogenous healing also can occur due to the continuous hydration from the cement or from the formation of the calcium carbonate or CaCO3 as a chemical notation. Then the third cause for the autogenous healing is based on the mechanical causes. So this could be due to the clogging of the materials coming into the cracks. So it can be from the broken fracture surface, or it can be due to the ingress of the debris from the water. Okay, and regardless of these causes, autogenous healing mechanism actually is very limited to heal the cracks of about 100 up to 150 micrometer in width. So this autogenous healing is very limited. That is why nowadays scientists they are trying to improve the healing ability by developing a new generation of the concrete, so-called the self-healing concrete. So, with respect to the traditional concrete, self-healing concrete possesses an autonomous healing mechanism. So, this autonomous self-healing occurs due to the addition of the healing additives, such as minerals, bacteria, polymers, crystal admixture, and etc. And also, we can also incorporate them into vessels or into like a capsule-like material. It could be also from the vascular network, shape memory polymers, and there are a lot of vessels that we can use in order to embed our healing additives. Okay, so for the self-healing concrete also, there are different pathways in order to achieve autonomous healing mechanism. From the intrinsic part, we can use fibers, super absorbent polymers, minerals. With regard to the capsules, we also can use minerals, bacteria, polymers. Again, we can use vascular network and shape memory polymers. So what is the benefit of the self-healing concrete? So the autonomous healing mechanism can easily heal the cracks up to 300 micrometers in width. And sometimes this autonomous healing mechanism can also heal the cracks of 1 millimeter or more. And also it depends on the environmental condition and also the type of the healing agents. Okay, so I hope you can understand a bit what is the distinction between the traditional concrete and also the self-healing concrete fundamentally. Okay, so let's have a look the variety of the self-healing materials that we can use to develop the self-healing concrete. So let's go one by one from the intrinsic part. So we start from the fiber. Well, fibers actually they are not working as we cannot use fibers as a self-healing agent, but it will help to restrain the cracks. Because when we are using fibers in our concrete materials and we try to crack our specimen, what's going on? The concrete will not fail directly, but due to the restraining force on each of the fibers, the crack can be controlled. So this is the video that I have prepared in advance. I will try to play it. I hope it works. Yeah. So if you see here from the concrete specimen, I have incorporated the fibers inside, and when I subjected this specimen to the Brazilian splitting test, the concrete will not fail directly, but it will generate a single crack. But the crack also starting from the micro size, and then it will grow slowly until a certain width. And with the fibers, we can try to control this. And imagine if we have a crack and the water comes into the crack, so what's going on? There will be some hydration products forming on the surface of the cracks due to the chemical processes from the calcium carbonate precipitation or also from the ongoing cement hydrations. Okay, so the fibers will be used, the use of the fibers is beneficial to control the cracks. Next, we also have a very innovative material so-called crystalline admixture. So this crystalline admixture is composed of the Portland cement and proprietary active chemicals. If you look now from my slides, I also show like a picture of the crystalline admixture. It looks like a cement because the color is a bit gray color, but there are some white particles containing in this material, and these white particles, they are the active chemicals that will work as a self-healing agent. Okay, and how this crystal admixture works for crack healing or for crack closure, here I will also provide like another video. So if you look at the video on the bottom here, now let's imagine we have a specimen, we have a concrete specimen, we crack that specimen, and it comes into the crack. So what's going on in the matrix? With the addition of the crystal admixture, later there will be some crystals grow inside the crack. And these crystals grow due to what? Due to the reaction with the calcium ions from the cement, from the aluminum ions also derived from the cement, and later it will react with the crystal admixture to form like millions of the crystals needle inside the crack. And later on, the crystals will grow as a whole matrix, and it becomes one integrity with the concrete materials. And imagine now from the video, if you have another crack forming on another side of the matrix, later another formation of the crystals will occur. So the use of the crystal mixture is based on the generation of the crystallization. It will generate a lot of the crystals, which is based also from the calcium carbonate, in order to block the cracks. So the water could not penetrate anymore into the cracks because of the clogging by the crystals. And in the dosage, typically we use this crystalline mixture in the range of 0.8 up to 1% by weight of the cement. Okay. Next, we have also another material so-called the superabsorbent polymers. So the superabsorbent polymer is also a chemical product which is made from the polymerization, and normally the SIP is available in the dry form in the picture on the left hand side, and when it gets in contact with water, what is going on? The SIP will swell significantly. It will swell so much until it becomes like a gel or a hydrogel. So what is the function or what is the objective of using this SIP into the concrete? On the picture on the right hand side, if you see, imagine concrete which has been added with the SIP. We have also a crack coming into the material and the water enters the crack. So what's going on? Later this SIP will swell and eventually blocks the ingress of the water. So we are sure the water will not penetrate rapidly into the tip of the crack. Okay, next we are going to move forward to the capsule-based healing agent, which are containing some minerals, bacteria, or polymers. Here, the use of the bacteria is very popular nowadays in float the self-healing concrete. And it depends also on the type of the bacteria that we can use, because not all family or not all types of the bacteria we can use for concrete production. It depends, because the bacteria should have an ability so-called MICP. So what is the MICP? MICP stands for microbial induced calcite precipitation. So the bacteria for concrete application should have this ability in order to promote the autonomous healing mechanism. So with the MICP process, in this example, we can distinguish into two parts. First, MICP could happen due to the metabolic conversion of the organic acid, if you can see from the left hand side. So here, the bacteria itself later will do some biomineralization in order to promote the carbonate. And on the right hand side, MICP could happen due to the enzymatic urolysis. So what does it mean by the enzymatic urolysis? So the bacteria, like a special type of the bacteria, could produce a small amount of the nitrate, that later this nitrate will be decomposed into the nitrate, and due to the denitrification, later the calcium carbonate ions will be produced, and the bacteria would act as a nuclei in order to attract calcium ions from the cement and carbonate ions from the denitrification. And the combination of this process will lead to the formation of the calcium carbonate eventually. Okay, so these two processes are very important for the biomineralization from the bacterial activity. Okay, so what types of the bacteria we can use for the production of the self-healing concrete? They can be Bacillus pericus, Bacillus megatherium, Bacillus cereus, Bacillus cochnei, Bacillus subtilis, and there are actually more types of the bacteria that we can use. I just give you some examples of the frequently used bacteria. And if you look here, there are some similarities between this bacteria, which is the family. It belongs to the family of the Bacillus. And why we normally use this Bacillus type bacteria? Because first, it can promote the biomineralization, as I mentioned, or MICP. Second, Bacillus bacteria is high alkaline tolerant. This is important because when we incorporate the bacteria into the concrete is very alkaline for the environment. So we have to ensure that the bacteria will survive in the high alkaline environment from the concrete. And with this Bacillus bacteria, the bacteria will remain stable inside the concrete materials. And if it is not being used, it will stay in the dormant stage. Okay, and the bacteria also will do a process so-called the germination, because the bacteria that we use start from the bacterial spores, and the spores will germinate into the cell, and then it will return back into the vegetative cell, return it back into the spore. So there will be some life cycles while we are using the bacteria. And bacteria certainly needs nutrient for the ground. So this nutrient is important for the food of the bacteria, because bacteria basically they need foods for the ground. And what kind of the nutrient we can use? We can use calcium lactate, calcium nitrate, calcium formate, urea, or yeast extract. Next, another type of the healing agent that we can use is so-called the microcapsules. So what is the physical meaning, or what is the objective of using the microcapsule? Now we can imagine. With the microcapsules, we will make such a very small capsules, as you can see from my slides. So inside of each capsule, we have embedded them with the healing agent. So if you see from the picture on the right hand side, if we already preserve the healing agent inside the capsule shell, and imagine we integrate or incorporate these capsules into the concrete materials, and when the cracks comes into the concrete, some of the capsules will break, and it will release a sufficient amount of the healing agent to the surrounding environment of the crack. And in this case, later, either healing or sealing process will take place. Okay, so with the use of the microcapsules, it depends also on the type or the material that we use for the shell or the cargo. For the shell, capsule shell, we can use either polyurethane, urea formaldehyde, or gelatin or gum arabic shell. With regards to the cargo, we can also use the sodium silicate, epoxy resin, calcium nitrate, or silane-based agents. So these types of the shells and the cargo are the ones that we have used frequently in self-healing application. And what is the typical size of the microcapsules is between 20 up to 200 micrometers, which is very small. And normally we use this microcapsule with a dosage of below 10% by weight of the cement. Here, this is a picture that I took during my PhD research. So we developed the microcapsules in the slurry condition, but at that time we have added the color pigment to the microcapsules. Because of what? Because when we put the microcapsules in our concrete mixture, and when the concrete will gets hardened at the later age, we can inspect what will be the condition of our microcapsule. For instance, this is the picture of the microcapsules which are available in my concrete matrix, and it glows under UV light. So we add such color pigment like efflorescence, so the material or the microcapsule later will glow in the dark. Okay. Next, in addition to the microcapsule, we can also make a macro capsules because the word is like a macro, so we make such a bigger capsules. But the capsules that we are developing in this case, they are classified as a tubular capsules. So what are some capsules? They can be a polymer capsules, something like this, where in here I have incorporated healing agent inside with the color of the blue and the green, and at both ends I also already clothed with some glue in order to preserve this agent inside the capsules. And together with my colleagues from Italy, we also fabricated the cementitious capsules. So this is the capsules which are made from the cement materials and with the other chemical products. And lastly, we can also use the glass capsules in order to make the macro capsules. Basically, we're just cutting such a long or tubular like a tube, like a very long tube, and then we cut into like a several tiny pieces, and then later we incorporate into the concrete. But how we can place these capsules into our concrete materials? Well, I think the most beneficial part when we are using the macro capsules is placing them in the cover zone of the concrete. So this is also an example of my colleagues. They are placing the capsules in the network of the wire at the cover zone of the concrete because the cracks will start from the surface, and the cracks later will penetrate first of all into the cover zone of the concrete. So the location of the capsule is very important. That is why they place in the cover zone to let the cracks enters, and the capsule will break by releasing the healing agent into the cracks. And this is also an example from my research. We also showcase the successful breakage of the capsules after the cracking by releasing the sealing agent or the healing agent into the cracks. You see, there was like a there was a wet formation at the bottom of the specimen, and this indicates like the sealing agent is flowing through the cracks. Next, we have also like the last two parts from the self-healing material types. So first, we have the vascular network. Vascular networks, actually it mimics our blood vessels in our human tissue. So we incorporated such quite a complex and a long tubing inside the concrete, and then the idea is more or less the same. So when the cracks occur, later the tubing inside the material will break, and then we can always inject the healing agent from one system, from the one which is on the left hand side here. So later the healing agent can flow via these tubes. And this is also an example from a colleague of mine from Belgium. They have a demonstration project by integrating this 3D printed vascular network. So later the shear wall of the concrete will induce some cracks, and we can inject the healing agent into this tubing system. And lastly, we have also the shape memory polymers. So the shape memory polymers is a special type of the polymers that it can remember what is the original integrity of the material. For example, if we have a rubber, if we stretch the rubber and then when we let it go, what will happen? The rubber will turn into the original position. So this concept we also try to integrate into the concrete, but not using the rubber, of course, but we use a material so-called the shape memory polymers. So this is basically some variety of the self-healing materials that we can use to produce self-healing concretes. Next, let's we have a look much deeper on the engineering properties of self-healing concrete. So let's we start. So imagine now we want to make a concrete mixture. So we want to make only a traditional concrete without any healing agent. And then let's we try to study what will be the effect of the crystalline admixture and also the bacteria. So here, this is at the table that you can see from my slides. I have integrated 1% of the crystalline admixture and also 2% of the bacteria. And then what should I do with this complete specimen later on? So first of all, we can try to crack our specimen via, in here, the test called the Brazilian splitting test, which is the one that I have showed before. And then after the concrete experience any cracks, what we can do, we can make some marks on our cracks, and then we use an optical microscopy in order to check the width of the cracks. And then let's have a look. So after cracking, we can see from the picture, yeah, there will be no healing activity because the concrete was just cracked at the time. And after we try to heal this specimen underwater, what happens? So for instance, after a short healing for about 21 days, what's going on? If you see on the crack lines, there was a limited crack closure. With the low precipitation of the healing product, you can really compare from the picture on the left and also in the middle part. So in the middle, there was some minerals formed inner the cracks and also on the crack mouth or on the crack location. And if we induce a longer healing time, what's going on? There will be a full crack closure with a very dense precipitation of the healing product. So this type of the healing agent can promote the autonomous healing mechanism. And how we can evaluate quantitatively about the healing process? So typically we calculate so-called the healing efficiency. So if you look from the formula, healing efficiency or HE, it's the 1 minus final crack width at a certain time divided by the initial crack width after cracking at 0 day, this times 100%. Then on the picture on the right hand side, if you see, I already compared what will be the effectiveness of the crystalline admixture and also the bacteria. If you see, yeah, the reference also will promote the one that I mentioned, autogenous healing mechanism. So that is why the healing efficiency it reached around 60%, say in this case. But with the use of the crystalline admixture and the bacteria, it will increase the healing efficiency due to the process of autonomous healing mechanism. Okay, so this shows that the addition of the healing agent is also effective to promote a better healing process. And in some cases, some minerals will also protruding or coming out from the cracks. For instance, this is the picture that I took when I studied my PhD, and at that time I tried to collect these minerals which was coming out from the crack. And with these minerals, what I can do, I can use instruments so-called FTIR or the Fourier transform infrared spectroscopy, and in this instrument I can evaluate about the atomic vibration of my mineral, and this vibration is depending on the wave number. If you see from the picture on the right hand side, there will be some intense peak at, let's say, 3690, 1460 something, 1700, and these peaks regarding the wave number as well, it is related about the mineral type or what kind of the mineral forming from the cracks. And from my study, I can confirm that this mineral was calcium carbonate in the polymer of aragonite. Okay, so now we know that the self-healing is real. I mean, like the crack closure could occur with the addition of the healing agents. But what is the practical application? Whether can we really implement the self-healing concrete into the field? And later on, if you go into the field, of course, when we build a building, we need reinforcement. We need steel rebars to make our structure much more ductile and much more toughness. So maybe you are wondering whether the self-healing effects is only effective to close the crack, or may it also contribute to the bone strength, the bond between the concrete and the steel reinforcement. Okay, so let's have a look. With the in order to assess the bond strength between the concrete and also the steel reinforcement, we can study about the bond strength by making bone pull-out specimen. So this is a special design in order to make a pull-out specimen. Basically, we use a steel reinforcement with the diameter of the rebar of 10 millimeter. And then we also use like a small PVC tube inside the steel reinforcement, and we make 5 types of the concrete mixture. So what are the 5 types? If you look from the picture on the right hand side, I designed my concrete C3037 with the first mixture. Of course, we have to make reference mixture. Reference concrete without any healing agents. The second mixture is the concrete with the addition of the bacterial biomass, which I denoted as the HTM. The third one, I also designed the fungi biomass, or concrete which is made from the fungi or jamur in Indonesia. And the fourth one, I designed concrete with the crystalline mixture. And lastly, I designed concrete with the bacteria. And let's see what's going on with this 5 mixture and what will be the contribution to the bone behavior. So, in order to determine or evaluate the bone strength, of course, we have to design like the setup for it. So, basically, what is the objective? We try to pull out the steel rebar from the concrete. For instance, I will show the animation here. So imagine now we have this system, and then later I will let the steel plate going up, so the concrete and the steel rebar will pull out each other. So it will be break on the reinforcement, especially inside. And from this setup, what we will get a lot of the information. For instance, we can evaluate the ultimate bone strength, which is very important. We can also determine mean bone strength, fracture energy, or we can also calculate the slip corresponding to the ultimate bone strength. But well, I cannot also explain a lot of concept in here, but let's see, we just focus on one parameter, which is the ultimate bone strength. So, with regards to the ultimate bone strength, here I already also give you some ideas what will be the effect of various healing agents. So, if you look here, our normal concrete, it has the ultimate bone strength of about 14 MPa, and with the addition of the fungi or bacterial biomass, it only increased slightly on the compressive strength, although it is not very significant. But if you compare now with the crystalline mixture with the blue bar and also the green bar with the addition of the bacteria, it significantly increased the ultimate bone strength. You see, from the 14 MPa into 22 or 21. And why it happens? If you want to know more about this, you have to go deeper into the microstructure of the concrete. So here I also show some pictures of the modification of the microstructure of the concrete. So if you compare with the reference HTN and the yeast, the contour or the matrix of the concrete, they are very amorphous. I mean, we cannot distinguish what will be the size, but they are covered mainly by the toboporite gel or the calcium silicate hydrate gel. But with the crystal admixture and the bacteria, they are very distinct if we compare with the reference and the other matrix. Because of what? They promote, or there was a massive formation of the crystal needles on the matrix. And this needle also will give an additional strength to our concrete. That is why the ultimate bond strength of the concrete made of crystalline admixture and bacteria has a higher strength than the reference and also the other biomase concrete due to the modification of the microstructure. So next, what we can do with the pull-out specimen, we can try to crack the specimen with a certain crack width, and with the cracking, typically we will see there will be a reduction of the ultimate bond strength at maximum 80%. And then we can also try to submerge this specimen underwater in order to promote healing. Now I will show you a very interesting figure. So after 28 days of healing underwater, you see on the crack line or on the crack mouth, there was a formation of the white particles. So these white particles, they are the minerals or calcium carbonate forming on the crack location. In particular, if you look on the crystal admixture, Ca and also BaC, you will see there was a formation of such a, well, we call it here as a stalactites. So there was a formation of the stalactites as a minerals forming on the crack mouth, and this is due to the injection or due to the formation of the minerals from the inside and its protruding to the outside. Okay, so there was a very strong activity of the healing with the use of the Ca and the BaC. And what's going on if we prolong the healing time? So this is only after 28 days. So what's going on after 112 days? Yeah, the crystals will grow so much. The minerals will grow abundantly until all the minerals would not stay only inside the crack, but it will coming out from the cracks and giving a lot of the stalactites structure. So this healing product, we can also confirm later with the FTIR that they are the calcium carbonate in the polymorph or calcite or aragonite. But in addition to the some proof that the self-healing is real, we can also determine or evaluate whether there will be a bone restoration or not. Because we can imagine on our concrete specimen, if they have some crackings, of course there will be some reduction in mechanical properties. So from my research, after healing, fortunately we found there was a bone restoration after healing, especially after 28 days. If you see here, from the 0 day, which is after cracking, some of the mixture underwent a partial bone restoration. However, above 28 days, for instance after 112 days, the bone strength after healing stay constant or remain stable. And why? Why it happens? Because actually the healing products, they are still quite weak. They cannot really bridge like two sections of the material after cracking. So it needs certain time until the healing products can be can have like a very dense packing, and also it has like a good bridging effect between those two surfaces of the specimens, especially within the cracks. So from the picture that I showed also here, I also showcase like even after healing, when I do the pull-out test, the crack will reopen again. If you see the picture on the bottom, you see there was a crack line being reopened even after healing. It also shows that the healing products inside there are not as strong as the concrete itself. Okay. Next, I'm going also to discuss a bit about the effect of the microcapsules, which is one of the type of the healing agents that we can use for the production of the self-healing concrete. So at the time, together with my colleagues from Cambridge, we developed microcapsules with the shell of the polyurethane and the cargo of the water repellent agent. And we also designed the mean diameter of these capsules was about 59 and 88 micrometer with dosage between 0.5 up to 1.5% by weight of the cement. And this is the picture of the microcapsules inside this slurry or inside this liquid. So what will be the effect of the microcapsules? Well, the use of the microcapsules will induce a strength decline or the reduction of the compressive strength. So if you see here, when by increasing the amount of the microcapsules from the 0.5 up to 1.5%, there will be a gradual strength reduction with increasing the capsule dosage. But why the strength is being decreased? You have to also go into the microstructure of your concrete. So by using the scanning electron microscopy, we can evaluate what will be the condition of our concrete matrix. In this case, if you see there, I found that there were several ruptured capsules within the microstructure or within the matrix. And this capsule will remain intact with the matrix and they will act as a defect or as a pores or as a hollows. And due to these pores, like a big pores from the microcapsules, eventually it will affect the mechanical properties of the concrete. That is why the strength of the capsule and the concrete made with the microcapsules, it will show a strength decline. So this is one of the reasons why the use of the capsules reducing the compressive strength. But when we are designing self-healing concrete, we should not only focus on the strength itself. We should also look another side or another view. What will be the benefit of using the microcapsules? So, in order to confirm the sealing ability of the capsules, we can design also the prisms. So at the time, I designed the prisms, and then I put like the epoxy on the bottom layer of the concrete, and the specimen has been cracked, and then I performed a test of called capillary water absorption. So I want to know how much or how fast the water can penetrate into the crack with this concrete type. So, if you look from the picture on the right hand side, it's very interesting because from the picture on the left, on the reference concrete, when I submerge and when I perform the capillary water absorption test, the water penetrates rapidly into the crack, and as you see, there was a wet area here. This represents that the water penetrates into the cracks and it's spreading all over the crack region. But with the MIC concrete or the concrete made of the microcapsules, you will see there was even no signs of the water absorption or the water penetration into the cracks. Why it happens? Because if you look from the microstructure, the capsules broke inside the matrix due to the cracking. And because of the breakage of the capsules, the sealing agent inside, it will be released into the matrix and it will seal the crack agent. That is why you see that there was like a very limited water penetration into the crack. And if we calculate how much the sealing efficiency based on this test, we found that the sealing efficiency reached above 85%, which is very good. Okay, so this is some proof like how we can integrate the the microcapsules in order to improve the durability aspect of our concrete materials. Next, we also have another type of the healing materials, so-called some macrocapsules. And in this case, I'm using the cementitious long capsules. This is a collaborative work with my colleagues from Politecnico di Torino from Italy. So how we can add these capsules into our concrete? So basically, let's start first making our fast mixture of the concrete. And then we add the capsules into this mixture, and then we also mix them again for about 2 up to 3 minutes in order the capsules distribute homogeneously inside the mixer. And then we can cast this mixture into the molds, either a cylindrical mold, cubic mold, or prismatic molds. And then how we can evaluate whether the integration of the capsules, the macro capsules in particular, they are effective or not, we can do the compression test or 3-point bending test. This is an example from my research. When I'm doing the compression test on the capsule-based concrete, you will see what is the result. The concrete itself will generate a lot of the cracks due to the high compression stress. But due to this stress, the capsules inside will break and releasing all the sealing agent into the micro cracks, into the pores, into the hollow. So that is why you see there was a huge formation of the wet area, and this represents that the sealing agent is releasing via the cracks. Because of what? Because the capsule broke inside that specimen. This is also the same case with the 3-point bending test, especially on the bottom side. You see also there was a wet area, and it also indicates the capsule broke at the cover zone of my concrete. And both pictures represent a successful capsule leakage. And with the same test, with the capillary water absorption, we can also check what will be the performance. And in my research, we also found that the sealing efficiency with the macro capsule can reach 75%, which is quite high if we compare with the reference concrete. So, in conclusion, well, concretes are naturally unavoidable. Concretes always grow, always occur in all of the structure. It's not possible we make a concrete in the perfect condition without any defects. It's not possible. So cracks always available in any structure. So what we can do is we can try to promote or later incorporate the self-healing materials in order to produce the new type of the concrete, so-called the self-healing concrete. And with the self-healing concrete, I have also showcased that the crack healing is very evident, it's real, and it will promote a durability protection and prolong the surface life of the concrete structure. However, the knowledge on the concrete mix design is also important, because when we add a certain healing agent, it's not just like adding bacteria into the concrete and then we let it go. No, we have to understand what will be the behavior, what parameters that I have to change in the concrete mix design. For instance, should I change the water demand? Should I change the content of the cement? So this knowledge is very important. Okay, for what? For optimizing the concrete performance. So from my future perspective, well, this is a bibliography analysis from a study by Alzard et al. So they also they have analyzed which countries or region have started the research on the self-healing concrete, And well, if I see from this bibliographic study, unfortunately in Indonesia, in particular, there was a very limited study about the self-healing factor. So that's why I would like to encourage to the lecturer, teachers, professors in Indonesia to advance the development of the self-healing fabric it can be by using the local materials, it can be using the secondary cementitious materials, chemical additives, and hopefully we can also make a patent for a novel self-healing materials. So this will be beneficial in order, as I mentioned, increasing, prolonging the surface life of the structure, improving the durability, and also giving a healing properties. So this innovation will later revolutionize the construction industry in Indonesia. Well, actually that's all from my side. If you are interested to learn more about the self-healing campaign, you can have a look on my paper. So this is a review paper that I published, I think, 4 years ago, and you can download it for free. So just try to have a look and try to understand a bit better what will be the impacts of the healing agents on the fresh and hardened properties of the concrete. And I also have a lot of the publication related about the self-healing concrete. So just try to Google my name and find my papers on the on the cloud. And if you want to ask me also about the self-healing concrete in private, you can also send me an email. So that's all from my side. I hope you enjoy my presentation, and I will return it back to the moderator. Thank you very much.
Thank you, Dr. Hermawan, for the wonderful presentation about I think it's like the new research using bacteria or something like biology. Itu sesuatu yang biologis. I will use bilingual for the session. Jadi sesuatu yang sekarang biasanya kita di teknik sipil makanya fisika sama kimia, sekarang ada ketambahan sedikit biologi ya, di bakteria, di microbes. Nah, sekarang sudah dikembangkan. Tapi tadi ada fragile dari 1 mili. Oh iya. Oke, barangkali dari teman-teman di sini ada pertanyaan yang di ruangan maupun yang di Zoom mengenai self-healing concrete.
Silakan kalau mau yang bertanya bisa dalam bahasa Indonesia atau bahasa Inggris. Saya memberikan keleluasaan kepada mahasiswa dan juga mungkin para dosen yang mungkin tertarik. Nanti akan saya coba jawab.
Masih bisa bahasa Indonesia ya Pak Hari?
Oh masih bisa. Kayaknya dari satu pertanyaan.
Baik, terima kasih waktunya. Perkenalkan nama saya Muhammad Afan Halwani dari mahasiswa Teknik Sipil UIN angkatan 24. Di sini saya akan bertanya misalnya.
Maaf, nggak kedengeran, kayaknya itu ke-mute deh.
Terima kasih waktunya.
Dengar tadi suaranya.
Perkenalkan nama saya Muhammad Afan Halwani dari mahasiswa Teknik Sipil UIN semester 3 angkatan 24. Yang dimana satu, apakah apa yang terjadi jika retakan tepat di sepanjang tulangan, apakah self-healing konkret masih efektif dalam menutupi celah tersebut? Yang kedua, apakah jika bisa menutupi bahan penyembuh seperti bakteri mempengaruhi daya lekat antara beton dan tulangan baja, yang gimana karena keduanya menahan daya tarik dan tekan pada sebuah struktur. Terima kasih, Mister.
Jadi terima kasih untuk pertanyaannya, sangat kritis ya untuk pertanyaannya. Jadi untuk yang pertama, pertanyaannya mengenai kalau misalkan kita punya retakan yang sudah masuk ke retakan, apakah itu bisa membantu dengan self healing? Jawabannya bisa, tetapi tergantung dengan tipe healing agent yang bakal bisa dipakai. Apakah juga agen penyembuhan ini bisa cepat untuk menyembuhkan retakan atau tidak? Karena sebetulnya untuk track healing ini kita membutuhkan apa? Kita membutuhkan keberadaan dari molekul air. Jadi track healing dia kenapa dia bisa memberikan dia bisa membentuk suatu mineral di dalamnya karena dia akan bereaksi dengan air, kalsium dan juga oksigen biasanya untuk membuat suatu presipitasi atau pengendapan mineral. Jadi kalau misalkan letaknya sudah masuk ke tulangan, sebetulnya itu sudah cukup kritis. Karena apa? Air bisa masuk ke retakan dan air akan mengenai tulangan dan mengalami korosi, sehingga kalau misalkan retakan tidak cepat diatasi, itu akan menyebabkan kegagalan dalam sistem struktur. Oleh karena itu, kita biasanya untuk riset self healing kita harus mencoba sebisa mungkin agar retakan itu tidak sampai ke tulangan. Makanya kita harus menggunakan self healing ini mulai dari cover zone. Jadi beton di lapisan paling bawah beton yang sudah dibilang cover zone untuk membuat self healing matrix, sehingga ketika retakan udah mulai dari bawah, kita harus bisa menutupi itu dari bawah dulu. Jadi retakan akan tertutup mulai dari surface, bukan dari ujung retakannya. Seperti itu. Jadi kalau kita sudah tahu mineralnya sudah terbentuk di dalam di permukaan dari beton, maka kita bisa mengasumsikan bahwa retakan itu sudah tertutup dan air tidak bisa lagi masuk ke dalamnya, sehingga kita bisa menjaga agar tulangan baja itu tidak terkena air dan tidak terjadi korosi yang sangat signifikan. Jadi itu untuk yang pertama. Yang kedua, apa hubungannya dengan daya retak tulangan baja dan matriks dari beton self healing? Jadi itu sesuai yang saya juga tadi jelaskan di presentasi saya. Jadi ketika kita menggunakan salah satu tipe dari agen penyembuhan atau material self healing ini, dia akan memberikan ikatan atau bond strength yang cukup besar. Karena apa? Karena dengan penambahannya agen penyembuhan, dia akan memodifikasi mikrostruktur atau matriksnya sehingga lebih banyak minerals, lebih banyak crystals, dan lebih banyak juga kalsium hydroxide terbentuk di dalam matriks, sehingga ikatan antara tulangan dan matriksnya dia akan lebih dekat. Seperti itu. Jadi kita bisa menilai secara kuantitatif bagaimana seberapa kuat antara tulangan dan juga matriks itu dengan mengetes yang dinamakan pull out test. Jadi kita mempull out atau kita menarik si tulangan itu dari material betonnya. Gitu. Jadi untuk daya tarik juga biasanya kita harus menggunakan tes lain, seperti misalkan kita menggunakan tensile test, tapi tensile test kita tidak bisa menggunakan dengan beton silinder atau beton kubus, tapi kita harus menggunakan suatu beton dengan bentuk tertentu. Contohnya seperti dog specimen atau spesimen dengan bentuk seperti tulang anjing kalau di bahasa Indonesia kan. Tapi kalau dalam bahasa Inggris namanya dog specimen. Jadi dengan dog specimen kita nanti bisa menarik itu spesimen untuk mengetahui seberapa besar tensile strength-nya. Seperti itu. Semoga itu menjawab pertanyaannya. Mungkin ada pertanyaan lain dari teman-teman mahasiswa atau dari para kolega dari UIN Malang.
Ada pertanyaan dari Zoom, Pak Heri.
Pak Heri.
Ya.
Terdengar suara saya?
Terdengar Pak, silakan.
Baik. Salam kenal, saya dengan Eko. Mohon maaf tadi joinnya agak terlambat. Jadi mungkin ada materi yang sudah disampaikan, cuma tidak sempat terlihat. Ini mohon maaf, ini moderator, saya langsung motong. Gak apa-apa nih, tanpa harus dipersilahkan. Gak apa-apa ya? Ya.
Bapak Pak, lanjut Pak.
Ya. apa namanya self healing material, dalam hal ini self healing komposit. Dan Biola tadi sudah sampaikan betul tentang apa namanya perilaku mutatif dari beton yang dihasilkan dari adanya tambahan. Tersebut bagaimana? Ada pengaruhnya nggak?
Ya.
Yang pertama itu, yang kedua, itu bukan saya kira Pak Ari agak aneh lah ya. Tekan, tarik, lentur,
ya,
dan yang lain-lainnya. Terus yang kedua, produsen yang memproduksi agen ini di Indonesia ada nggak merek-mereknya? Nah, apa yang disebutkan walaupun dianggap sebagai promosi atau tidak? Sebutkan saja nggak apa-apa, ini sebagai bahan pengetahuan bagi bagi saya juga pribadi, yang juga boleh didengar adanya bisnis hasil.
Baik.
Nutup sendiri kan? Silakan Pak.
Ya, terima kasih Pak Niko untuk pertanyaannya. Jadi untuk perilaku dari mekanik terhadap beton self healing ini, saya bisa bilang itu tergantung dari agen penyembuhan mana yang bakal kita pakai. Jadi berdasarkan riset yang saya lakukan dan juga berdasarkan literatur review, jadi kita menemukan bahwa kalau kita menggunakan agen penyembuhan, contohnya seperti bakteria, crystal admixture, atau minerals komponen, dia akan meningkatkan kekuatan, kekuatan tekan atau dia kekuatan tarik. Karena apa? Karena dia akan memproduksi suatu kristal di dalam matriks yang bisa mempengaruhi kekuatan atau integritas dari beton itu sendiri. Tetapi kalau kita menggunakan agen penyembuhan lain, contohnya microcapsules, macrocapsules, superabsorbent polymer, dia akan menurunkan kekuatan beton. Nah, apa? Contohnya, kalau superabsorbent polymer, dia memiliki ability untuk shrink and swell behavior. Jadi dia akan mengerut, lalu dia akan mengembang lagi. Jadi itu bakteri kembang. Apa yang kalau kita menggunakan selfie ini akan kekuatan beton akan menurun karena banyaknya pori-pori dari beton akibat swelling and also shrinking behavior dari SPP ini. Tapi kalau untuk penggunaan microcapsule itu juga akan menurunkan kekuatan karena kapsul-kapsul itu sendiri dia memiliki kekuatan yang jauh di bawah dari material beton. Oleh karena itu, microcapsule sendiri dia akan bertindak sebagai defects atau pori-pori di dalam beton yang akan meningkatkan kekuatan beton itu sendiri. Tetapi di samping itu ada benefit yang lebih jauh daripada kekuatan, yaitu dari sisi durabilitas. Oleh karena itu, ketika kita mendesain suatu self-healing concrete, tidak hanya kita berpaku pada kekuatan mekanik, tetapi kita juga harus tahu bagaimana durabilitas atau daya tahan beton itu untuk di kemudian hari. Seperti itu. Dan untuk pertanyaan kedua mengenai produsen di Indonesia, sejujurnya saya juga kurang tahu karena saya sudah lama tinggal di luar negeri. Jadi ketika saya melakukan PhD di Belgia dan juga di Valencia di Spain, sudah cukup banyak produsen yang membuat healing agent itu sendiri. Contohnya, jadi kalau di luar negeri itu di Belanda ada satu perusahaan yang dinamakan Basilis. Jadi perusahaan Basilis ini dia memproduksi bacterial based healing agent atau agen penyembuhan berbasis bakteri. Lalu di Amerika, Italia ada perusahaan yang dinamakan Penetron International. Jadi Penetron International memproduksi juga crystalline admixture sebagai salah satu agen penyembuhan. Lalu di Inggris ada juga perusahaan yang dinamakan Minitrate atau Micropore, dia memproduksi mikrokapsul. Jadi sejauh ini, sepengetahuan saya, belum ada perusahaan di Indonesia yang bisa mengembangkan suatu agen penyembuhan. Tetapi salah satu cabang dari Penetron Internasional, dia memiliki cabang di Indonesia. Jadi mungkin kalau Bapak tertarik, Bapak bisa coba cari info mengenai Penetron Indonesia. Dia biasanya akan mensuplai crystal admixture untuk suatu proyek-proyek yang membutuhkan durabilitas yang tinggi.
Baik. merek-merek yang terkenal di Indonesia seperti Sika, Posrot, nggak ada ya?
Sika seperti sepengetahuan saya belum ada, tapi mungkin kita bisa pakai untuk sealing agent, bukan healing agent. Jadi ada dua perbedaan antara sealing dan healing. Jadi kalau healing, ketika kita menyertakan dia akan tertutup seperti itu. Tapi kalau untuk sealing, terkadang dia masih terbuka, tetapi di sekitaran permukaan dari retakan itu dia sudah memiliki water bearing effect. Jadi air tidak bisa lagi masuk ke dalam retakan. Karena apa? Karena dia menjadi hydrophobic. Nah itu di riset yang saya lakuin untuk PhD, kita menggunakan sealing agent itu merek Sika, yaitu Sika Guard. Jadi Sika Guard ini dia bisa memberikan proteksi terhadap beton terhadap air yang masuk melalui pori-pori seperti itu.
Hampir mirip seperti SHP ya?
Bukan, beda. Kalau SAP ini kan super absorbent polymer, jadi SAP ini dia akan mengambil air, dia akan menyerap air yang berlebih sehingga dia akan mengembang. Tetapi kalau si Guard ini dia akan masuk ke dalam pori-pori beton dan dia akan memberikan suatu proteksi. Jadi air ketika dia nanti menyentuh permukaan si beton dengan si Guard, dia akan tetap di luar, dia tidak menyerap.
Oke, baik. Terima kasih banyak Pak Ari.
Sama-sama.
Ya, terima kasih Pak Eko. Mungkin ada satu pertanyaan lagi, kita sampai jam 11.15. Silakan yang dari ruangan.
Ada yang bertanya lagi, Pak Tinggal?
Ada Bu, di ruangan.
Oh, ada.
Ada satu terakhir.
Suaranya Pak Tinggal nggak kedengeran.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Kenalkan, nama saya Yustisia.Bermanfaat dari angkatan 24 semester 3. Di sini saya ingin tanya, apa perbedaan self healing ini dengan sistem growing, dan jika sama atau mirip, manakah yang lebih kuat untuk dilakukan pada injek struktur eksternal seperti topi-topi, dan apakah mungkin digabungkan metode self healing dan growing? Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Mohon maaf, bisa mungkin mau iya, saya kurang terlalu kecil suaranya.
Iya, saya juga dengar itu tadi. Mungkin diulang ya Pak Tinggal.
Kalau gini kedengeran Bu? Atau Pak Dokter? Kedengeran atau masih turun?
Ya, sudah mulai dengar suaranya.
Yang mana yang nyalain? Itu aja ya.
Baik, saya ulang. Apa perbedaan self healing ini dengan sistem growing, dan jika sama atau mirip, manakah yang lebih kuat untuk dilakukan pada injek struktur eksternal seperti topi-topi, dan apakah mungkin digabungkan metode self healing dan growing? Terima kasih.
Pantauan coba Mbak. Udah dapat Pak Ari.
Pertanyaan pertama tadi perbedaan self healing dan apa ya tadi? Saya kurang kedengeran.
Sistem
oke. Ya, oke. Saya kayaknya cukup ini saya cukup tahu pertanyaannya. Jadi, terima kasih pertanyaannya. Untuk yang pertama, apa perbedaan dari self-healing concrete ini dan grouting? Tentu saja mereka berbeda. Jadi untuk grouting ini kan biasanya kita buat piling atau untuk grouting di suatu dinding, suatu shear wall katakanlah. Tetapi untuk beton self-healing ini adalah dia satu integritas yang sama. Dia udah satu struktur yang besar. Jadi aplikasi ini cukup berbeda karena untuk grouting sendiri ada material khusus yang bisa kita pakai untuk sistem grouting. Karena grouting ini kita pakai bukan untuk self-healing tujuannya. Itu adalah untuk menahan suatu loading dari struktur agar dia tetap stabil. Tetapi untuk self-healing ini kita akan mempromosikan suatu fenomena yang dinamakan dengan self-healing, dan juga kita akan mencoba untuk meningkatkan service life dari struktur itu sendiri. Jadi untuk beton self-healing, kalau kita bandingkan antara grouting dan beton self-healing, kita tidak bisa menyamakan itu karena dia objektifnya dia berbeda. Itu yang pertama. Yang kedua, seberapa kuat dia injection terhadap strukturnya lagi. Jadi kalau untuk beton self-healing ini, kita kan menambahkan suatu material penyembuhan atau agen penyembuhan terhadap si beton. Jadi kekuatannya akan menjadi satu kesatuan, satu integritas. Jadi kita bukan mendevelop sesuatu yang kita harus memilah antara kalau kita misalkan bikin beton self-healing dan untuk bikin suatu struktur dengan yang tanpa self-healing, itu akan jelas berbeda. Jadi itu tergantung dari perilaku dari struktur itu sendiri. Gitu. Lalu pertanyaan terakhir itu tentang grouting mana yang lebih baik ya tadi sepertinya. Jadi untuk grouting ini kita harus menggunakan suatu material khusus. Biasanya untuk grouting kita bisa menggunakan bakteria. Tetapi bakteri yang dipakai tidak sama dengan bakteria untuk beton self-healing. Karena untuk grouting ini dia harus memiliki kekuatan yang sangat besar jika dibandingkan dengan beton pada umumnya. Misalkan kalau kita mendesain suatu beton dengan 50 megapascal, 50 MPa, tapi dengan grouting kita biasanya harus meningkatkan kekuatannya lebih jauh karena dia akan menjadi penopang untuk si struktur itu. Seperti itu. Jadi ada beberapa riset yang sudah menggunakan grouting, tetapi sebetulnya itu belum bisa dibuktikan secara ilmiah atau belum bisa diaplikasikan di dunia nyata. Karena kebanyakan kasus untuk beton self-healing ini kita banyak, terutama di Eropa dan juga di Amerika, beton self-healing sudah banyak diaplikasikan di beberapa bangunan utilitas. Contohnya apa? Contohnya seperti bendungan, tangki air, reservoir air, jembatan, dan seperti itu. Jadi untuk pengaplikasian grouting itu masih hanya dalam skala riset, belum bisa diaplikasikan di dunia konstruksi yang sesungguhnya. Seperti itu. Semoga jawabannya membantu ya. Tapi kalau misalkan masih ada bingung, boleh tanya lebih lanjut.
Terima kasih Pak Hari. Mungkin itu sesi tanya jawab. Kalau ada pertanyaan lagi bisa dilanjutkan.
Ini sedikit nyambung dari pertanyaan Pak. Oh, ternyata ada pertanyaan. Ini dulu deh, Pak Hari. Ya, ada di ini. Ini Bapak Dilan.
Jadi saya baca di grup, jadi di meeting chatnya ya. Jadi ini atas nama Eva bertanya, mana mekanisme healing yang efektif after shock, apakah kimia atau biologi? Maksudnya after shock ini apa maksudnya? After shock, kimia atau biologi? Jadi untuk self healing ini tergantung dari materialnya seperti saya bilang. Kalau untuk bakteria, dia akan bereaksi secara biologis. Karena apa? Dia akan mengalami suatu proses yang dinamakan metabolic conversion atau denitrification, atau yang saya bilang tadi adalah MICP, microbial calcite induced precipitation. Jadi presipitasi ini bergantung dengan aktivitas biologis terhadap bakteri. Tetapi bakteri ini membantu juga secara kimiawi. Karena apa? Karena bakteri ini dia akan nanti mengambil kalsium ion dari semen, dari proses biologi dia akan memproduksi ion karbonat. Nanti ketika dia bereaksi dengan air dan dia mengambil juga oksigen terhadap itu, dia akan bereaksi secara kimia untuk membentuk suatu kalsium karbonat atau kalsium karbonat. Jadi untuk sel filling khususnya bakteria, dia akan bekerja secara biologis dan secara kimiawi. Tetapi untuk materi-materi yang lain, contohnya crystalline admixture, microcapsules, superabsorbent polymer, dia hanya bekerja secara kimiawi karena tidak ada mikroorganisme yang bekerja untuk sel filling khususnya untuk materi tersebut selain bakteria. Oke. Untuk efektif yang mana? Menurut saya itu tergantung dari aplikasinya. Jadi kalau menurut pengalaman saya, yang paling efektif adalah bakteria. Karena dia bekerja dua cara, secara biologis dan secara kimiawi. Tetapi yang harus kita tekankan di sini adalah ketika kita menggunakan bakteria, harus penggunaan bakteria yang cocok, yang bisa survive di dalam lingkungan beton, dan juga kita harus menambahkan nutrien atau makanan untuk bakteri ini sehingga dia bisa berkembang. Karena kalau kita tidak menambahkan nutrien, kalau kita juga tidak melakukan treatment pada sel-sel bakteria di dalam beton, dia akan mati. Dan ketika dia sekali mati, dia tidak akan bisa bekerja kembali. Jadi untuk bakteri cukup tricky, tetapi sampai sekarang ini sudah ada perusahaan yang tadi saya bilang, Basilis di Belanda yang sudah mendevelop dan dia sudah juga mengecek struktur beton dengan penambahan bakteria, dan mereka mengklaim mereka sudah mengecek struktur ini selama 10 tahun, dan selama 10 tahun bakterinya masih hidup. Seperti itu. Jadi sudah ada proof of concept-nya. Lalu pertanyaan kedua, apakah sensor non-destructive testing dapat digunakan untuk mendeteksi dan evaluasi aftershock? Mungkin maksudnya untuk mengevaluasi apakah healingnya bekerja atau enggak, seperti itu ya. Jadi pertanyaan yang sangat bagus. Jadi penggunaan dari non-destructive testing seperti penggunaan ultrasonik, terus penggunaan juga sensors, dia akan sangat membantu. Karena apa? Karena kita tidak bisa menilai self healing ini secara kuantitatif, kayak misalkan seberapa padat dari pengendapan karbonatnya di dalam retakan, atau seberapa banyak. Jadi kita biasanya untuk mendukung hasil riset kita bisa menggunakan ultrasonik. Jadi contohnya untuk beton-beton yang sudah terheal, kita bisa menggunakan ultrasonik dan kita bisa menilai seberapa cepat laju ultrasonik dari suatu sensor ke sensor yang lainnya. Karena biasanya kalau transit time dari transmitter ke receiver dia semakin cepat, artinya nanti ultrasoniknya akan semakin tinggi. Jadi kalau velocity atau kecepatan ultrasonik meningkat, artinya apa? Artinya densitas atau packing dari si beton itu sendiri dia juga akan semakin padat. Jadi kita bisa mengecek juga efektivitas healing dengan menggunakan non-destructive testing. Bahkan ini lebih dianjurkan di banyak riset kalau kita menggunakan material ini, menggunakan teknik ini untuk mendeteksi apakah healing itu bekerja atau tidak. Karena kalau kita sudah menambahkan agen penyembuhan dalam beton, contohnya di struktur, akan sangat sulit untuk misalkan gini, kita coring suatu material, kita mendeteksi, kita tes secara mekanik, itu akan sangat susah untuk membuktikannya. Tapi kita bisa membuktikan secara ilmiah lewat uji non-destructive testing.
Pak Haris tadi saya chat.
Oh iya, baik.
Putus-putus tadi.
Baik Bu. Mungkin tadi ada nambahan ya dari Eva, satu lagi bakteri itu berbahaya tidak buat manusia.
Iya.
Bakteri yang dipakai untuk beton tidak berbahaya untuk manusia. Nah itu sudah diklasifikasikan. Ada bakteri yang berbahaya dan ada tidak. Ya. Dan biasanya untuk bakteri Bacillus dia tidak berbahaya untuk manusia. Tetapi tetap kalau kita menggunakan ada bakteri ya, kita harus menggunakan PPE yang pas atau protection equipment ketika kita bekerja di laboratorium. Ditakutkannya misalkan bakterinya entah masuk ke dalam tubuh kita atau gimana, itu kita kita harus tetap jaga kondisi seperti itu. Baik, lalu untuk Ibu Taranita, apakah agen healing ini dipengaruhi kondisi iklim kah? Yes, jadi aktivitas healing ini juga tergantung dari kondisi lingkungan di sekitar kita. Nah, contohnya, kalau misalkan kita menggunakan beton selfie di Indonesia, menurut saya ini akan efektif. Karena apa? Di Indonesia itu kita memiliki iklim yang tropis, yang tingkat humidity-nya itu cukup tinggi. Dan dengan tingkat humidity tinggi, kita juga punya moisture content yang cukup tinggi. Jadi di lingkungan di Indonesia ada sangat banyak molekul air yang tersedia di udara. Dan ini akan juga mempercepat laju dari healing. Tetapi kalau misalkan kita mengaplikasikan beton ini misalkan di negara contohnya seperti di Saudi Arabia yang sangat panas, nah mungkin ada treatment tertentu yang harus kita lakukan agar si agen penyembuhan ini bisa responsif terhadap lingkungannya. Nah, jadi salah satu clue yang harus kita ketahui adalah apakah agen penyembuhannya bisa bereaksi dengan air dan apakah dia cocok dengan kondisi negaranya atau tidak. Kita harus coba dulu. Kita harus coba letakkan satu spesimen kita dan misalkan kita tahu di luar, di lingkungan terbuka dan kita lihat misalkan setelah 7 hari atau 14 hari apakah retakannya bisa tertutup atau enggak. Seperti itu. Atau kita bisa simulasi di laboratorium. Misalkan gini, di Indonesia juga kan kita sering cukup banyak hujan, curah hujan cukup tinggi. Nah, kita bisa mensimulasi di lab, contohnya gini, kita bikin satu batch beton yang kita taruh semuanya di dalam air. Batch kedua kita taruh semuanya di luar, di dalam terbuka. Satu lagi batch yang kita kasih dia lingkungan yang wet and dry. Misalkan 4 hari di dalam air, 3 hari di luar. Nanti kita bisa lihat kondisi mana yang sebetulnya optimum untuk agen penyembuhannya. Karena tidak ada standar misalnya ini, oh bakteri hanya bisa khusus di udara luar. Tidak, itu tergantung dari banyak faktor. Gitu. Jadi kita harus tetap double check apakah itu cocok atau tidak. Seperti itu. Lalu mungkin bisa diproduksi secara massal tergantung lokasi di mana. Nah itu juga tergantung dari resource-nya. Apakah kayak lokal dari area-anya itu mempunyai kayak misalnya ini, contohnya untuk bakteri kan kita bisa ambil dari di mana spesimen, kita bisa ambil dari tanah, kita bisa ekstrak dari tanah untuk mengambil bakteri itu sendiri dan kita lakuin kultivasi sendiri. Tetapi kita juga harus tahu apakah misalkan bakterinya ini tergolong dari bakteri bacillus kan atau bakteri yang misalkan berbahaya kan. Nah itu kita harus uji mikrobiologi lebih lanjut. Jadi biasanya kita harus berkolaborasi dengan biologis untuk mengetahui apakah bakteri ini cocok atau tidak. Seperti itu. Ada beberapa klasifikasi, contohnya gram positif test, gram negatif test. Juga ada kita bisa cek bakteri kalau kita punya suatu alat kimia, nanti kita taruh suatu bahan kimia namanya agar. Nanti kita taruh bakteri di situ, kita tutup, kita kultivasi, kita lihat apakah dia berkembang atau enggak. Nah, hal-hal seperti itu yang harus kita cek lebih dulu untuk mengetahui apakah bakterinya kompatibel atau tidak. Seperti itu.
Baik, terima kasih Pak Harim. Sepertinya ada satu pertanyaan lagi di chat.
Baik, ada kelemahan nggak penggunaan bakteri pada beton? Well, so far dari pengalaman saya penggunaan bakteri yang diproduksi di Belanda sejauh ini sih tidak ada efek sampingnya. Tetapi mungkin apa yang harus kita ubah dari bisnis kita adalah water demand atau kebutuhan air. Karena ketika kita menambahkan suatu material baru, ada kemungkinan material tersebut membutuhkan air yang cukup agar dia bisa hidrasi. Dan kalau kita membutuhkan lebih banyak air, kita juga harus mengetahui apakah parameter water to cement ratio atau rasio semen dan air masih bisa terjaga atau enggak. Seperti itu. Tapi untuk perilaku mekanis, perilaku healing, saya bisa bilang penggunaan bakteri akan sangat efektif untuk membantu meningkatkan durabilitas atau daya tahan beton. Baik, terima kasih Pak Eko atas pertanyaannya, semoga sangat membantu.
Keren Pak.
Terima kasih Bu Saranita.
Make sound Mbak ini.
Terima kasih Dr. Hermawan. Kita lanjutkan untuk ke sesi penyerahan sertifikat. Nah,
Silakan Pak Eko. Baik Pak Hari. Terima kasih banyak ya atas kesediaannya untuk membersamai kami pada hari ini. Di sana jam berapa?
Di sini tepat jam makan
istirahatnya.
Oh ya, nggak apa-apa. Kebetulan saya hari ini nggak ada ini sih.
Oh, tempatnya makan.
Iya. Dan di sini jam 12
Iya.
tepat jam makan siang.
Alhamdulillah ya. Ya mungkin next kita bisa kolaborasi di penelitiannya ya Pak Ali ya. Tadi tidak mungkin dengan Pak Malik tadi ya, karena banyak sekali sekarang sudah dibuka pembiayaan terkait dengan penelitian-penelitian dari LPDP itu, dari LPDP, sehingga memungkinkan untuk collaboration research yang lebih besar. Tidak ada yang bisa kami sampaikan kecuali sertifikat, mohon dapat diterima, mohon dan berkenan ya.
Terima kasih
mungkin
ini itu suatu kehormatan buat saya untuk diundang di webinar ini, dan semoga ilmu yang saya sampaikan juga bisa bermanfaat. Dan kalau misalkan ada salah-salah kata, dan kalau misalkan ada sesuatu yang pengen diskusi yang lebih lanjut, feel free buat email saya, nanti akan saya coba balas juga.
Baik, terima kasih Pak Hari. Semoga ilmunya bermanfaat untuk semua. Dan mungkin tidak hanya satu kali ini, mungkin kami akan kontak.
Baik.
Dan lain kali mungkin akan dilanjut.
Baik.
Baik, terima kasih sekali lagi. Saya mewakili Prodi juga mohon maaf apabila masih banyak kekurangan. Terima kasih.
Ya, terima kasih kembali.
saya kembalikan ke Bu MC, Bu Aini.
Okay, thank you, Mr. Hari Hermawan. Okay, ladies and gentlemen, as we reach the end of today's webinar, let us take a moment to express our gratitude to Allah Subhanahu wa Ta'ala for today's meaningful event. To lead the prayer, please welcome Muhammad Romi Mazaya.
Wah, ini belum foto, lupa ya?
Oh iya, mohon maaf. Ya, mohon maaf, kamerawan. Selanjutnya kita sesi foto bersama dulu. Dimohon untuk hadirin dari Zoom meeting untuk menyalakan kamera untuk kita ambil dokumentasi sebentar. Oke. Sudah, kita hitung dalam hitungan 3 detik. 1, 2, 3. Lagi, satu kali lagi. 1, 2, 3.
Terima kasih Bu Ai.
Oke, terima kasih. Sekali lagi kita close untuk keynote speaker kita, Mr. Malik. Selanjutnya, mari kita tutup acara kita pada siang hari ini dengan pembacaan doa yang akan dipimpin oleh Muhammad Romi Mazaya.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين حمدا يوافي نعمه ويكافئ مزيدا يا ربنا لك الحمد كما ينبغي لجلال وجهك الكريم وعظيم سلطانك اللهم صل وسلم على سيدنا محمد بفضلك ورحمتك يا الله أنك علمتنا ما لم نعلم قبله سبحانك لا علم لنا إلا ما علمتنا إنك أنت العليم الحكيم علينا وأكرمنا بنور الفهم ووفقنا بالعلم والعمل اللهم إنا نستودعك ما علمتنا فارده إلينا عند حاجاتنا إليه ولا تنسناه يا رب العالمين واهدنا إلى صراط مستقيم اللهم إنا نسألك سلامة في الدين وعافية في الجسد وزيادة في العلم وبركة في الرزق وتوبة قبل الموت ورحمة عند الموت ومغفرة بعد الموت اللهم هون علينا في سكرات الموت والنجاة من النار والعفو عند الحساب ربنا لا تزغ قلوبنا بعد إذ هديتنا وهب لنا من لدنك رحمة إنك أنت الوهاب ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على سيدنا محمد وآله وصحبه أجمعين سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين الفاتحة.
Akhir kata atas nama. Oh ya, sebelum kita tutup, kami umumkan kepada seluruh peserta baik yang offline maupun online di Zoom meeting untuk